to be able
And
to
here
help out with
we
this
have
emergency.
one of the most extraordinary events to take place on our planet. The gift of 100 subscriptions to Paleontologizing.
Oh, so fired. There was a big pile of rocks on top of it. Fisher. Oh, and it's on live stream too.
Oh. And Iliumworks says it's so worth it. The world needs all the science outreach it can get. Did anybody else see that coming? Just ambushed. My goodness. I don't think that's ever happened to me. That, so quickly on its feet. It's like pieces of a puzzle that I love to try and solve. So much fun to think about how a species has evolved, and all the kids who want to see them lining up at our museum. You wouldn't download a Triceratops, says who got the Dormiano. Oh, I would. I have. Again, it goes back to like the feelings of superiority, where like an easy way for people who might not be the brightest to feel really superior over others is like to have a conspiracy theory, you know. It gives you like a special knowledge that you have that like only I know this. And that makes me so special because the rest of the world is wrong. But I get this special knowledge to myself, and it lets me not be a sheeple. Like, you're a sheeple and you're a sheeple, but I'm not a sheeple because I've got special knowledge, you know? Like, num 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 num, I love it, yeah, I want to have this special knowledge. It doesn't matter if it's true or not, because it's about the emotional appeal, you know? That, num 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 num, I love it, this is good. That's what it's all about. So yeah. Wouldn't otherwise have. That's pretty cool. That's one of the things that makes us human, that we can not only ask, where did we come from? How did everything here come to be? We can actually find the answers. That's incredible. That's really amazing. And it's, I think, one of the most noble pursuits that anybody could have. That's why I'm proud to be a paleontologist. So yeah. I hope that works. Yeah.
Can you hear those calls they're making? That's what bald eagles actually sound like. When you see bald eagles in a movie or a TV commercial or something like that, usually they add in the wrong sound. The sound of a red-tailed hawk. That kind of, you know, piercing, angry shriek that you hear is not from an eagle. That's from a red-tailed hawk. Bald eagles have got kind of a... well, you'll hear it in a second, hopefully. It's hard to describe, but it's like it's almost like a shrill giggle, the sound that they make.
To become a paleontologist is to start working in a museum. If you have a museum near where you live, try to start working in that museum. Whether it's as a volunteer, or even a custodian, or whatever you can do to put yourself in that museum and start talking to scientists, start talking to other paleontologists. Become involved in the museum there, and that can be your fast track to a career in paleontology. That is what I started doing when I was in high school. I was, I think, 14 years old when I started working at the University of California Museum of Paleontology in Berkeley. Here I am working on, I've never seen them swim away so fast. It's kind of... it's interesting to see. He's not happy. I'm gonna just kind of push him back to shore. Like a tugboat. so fast.
Pretty cool. So, dwarf mammoth and supersized imperial mammoth. Pretty neat. I guess it goes to show that, like, the proboscidean bow plan, body plan, is really versatile. I mean, it can work at a massive scale like this, and it can work much smaller, too. Oh, that's pretty cool. That's pretty cool. Yeah. Yeah.
Fish, yeah.
Biologists and paleontologists, this creature was a very old and
Wait, hang on a second. Biologists here, and this is what a paleontologist looks like? Really? Do I look like that, chat? I don't know. Maybe I do. Anyway, you didn't want to say anything, Moosey Fate? Yeah.
Look at that sorry brush. Holy cow.
This is what they're supposed to look like.
It's got a nice haircut. Yeah.
Pack rats got in and ate it all.
Hire him as my barber.
Oh. Yeah. Look at all this loose fur. Whoa. Minnie, careful. She just straight up fell off the desk. Minipod.
We're just seeing that the diversity of dromaeosaurs is so high compared to what we thought, in the past.
That's so cool.
When I named Utah Raptor, it was the sixth one ever named.
The sixth dromaeosaur ever?
Sixth dromaeosaur ever.
Shoot.
And now there's over 40, that are dromaeosaur.
Yeah. Did you, is that part of the start of the trend to name them raptor as the suffix? Was Utahraptor the second one with that suffix?
I'm not sure.
It was Velociraptor and then...
Yeah.
Utahraptor might be the second one.
Yeah, because, we were thinking, the Crichton book, and the whole bit.
Yeah.
And, and Bacher didn't name it, but he did say, you might want to name it for Utah. Because there was some political stuff. I was in Colorado. And my former state paleontologist and head of me didn't want anyone working for a group like Dynamation that I worked with the museum, working in Utah. So, it's like, maybe if you name it after Utah, they'll, take it better. And I have to admit, it's probably why I'm now the state paleontologist of Utah, so it wasn't a bad move.
It's a wise decision, yeah.
Yeah.
Big ol'... Oh, do you see that lightning? Yeah. We've got lightning, boys. Let's see when the thunder comes.
I haven't been counting.
Of the dinosaur taxonomy universe is long, but it bends toward consolidation.
Foam.
You cut the foam to the shape of the bone, or the pedestal rather, and then you mix up a bowl of plaster, you dip it in there,
Gotcha.
and with the coarse side up, you press it all over the jacket.
You said foam, and I was thinking spray foam.
Oh, yeah. Yeah, polyester.
Gotcha, yeah.
AC.
No, that makes a lot more sense.
It behaves a lot like fiberglass, but it doesn't have the risks of fiberglass.
Ugh. Yeah, I've used a lot of fiberglass in the lab before, and I don't enjoy it.
We use it here occasionally, and I don't enjoy it either.
All right. Oh, man, look at that.
I don't know how much we're going to see. Oh, there's some stuff peeking out.
Nice. We got some bone already, yeah.
Yeah, that must be part of the sacrum there.
Right over here, Tim.
Yeah,
The transverse process or something?
It's either float process or part of the cradle.
Okay.
This looks vertebral centrum right here, possibly. Jack says a lot of stuff, so we always find new things. All right.
Dinosaur paleontology isn't rocket surgery. It's not that complicated.
So imagine a world without grasses, basically. And prior to the early Cretaceous, you go back to the Jurassic period, no flowers. A world without flowers and without grasses. No flowering plants. The angiosperms are the group of plants that, you name a plant and chances are it's going to be an angiosperm. That whole group didn't even evolve until the early Cretaceous period. So instead, You had what we call gymnosperms and other plants like that. You had conifers, you know, like pine trees, redwoods, stuff like that. You had ferns, you had cycads, horsetails and club mosses and spike mosses. But stuff like this, the sagebrush, this is a flowering plant, as I understand it. This is an angiosperm. These guys did not exist during the Cretaceous period. They had not evolved yet. Like, there were dinosaurs that lived at the same time as our early mammalian ancestors, and the smartest of the dinosaurs were smarter than the smartest of the mammals, we think. And they were as intelligent as they needed to be in their environment because they were remarkably successful. Dinosaurs ruled the Earth for over 150 million years, so they were plenty smart. Sometimes being too smart can actually be a disadvantage. I mean, shoot, look at us today, where we're in the process of absolutely wrecking our planet. And being smart can also, you know, can lead you to do things like polluting the environment or creating nuclear weapons. You know, maybe human intelligence will turn out to be a mistake. Who knows? Time will tell. Let's see. This is just the neck. So let's start here at the head. And then move down toward the body. It just keeps going. Just keeps going and going. And then the body would be under there. Holy moly. And look, like the room wasn't even long enough for the entire neck. Just keeps continuing under there. How cool is that? How cool is that? Caravan says, what a great display idea. It's really cool just being able to walk over this. It gives me a different perspective on the animal. That's like a neat bit of interactivity there. I don't think I've seen a plesiosaur displayed like this before. I think that's so cool. That's so cool.
And when somebody asks you about it, you could say, yes, this one here is a replica. The real thing I donated to a museum, or I funded its excavation. That's because of me. And they were so grateful for that that they gave me this to show off. How much cooler is that? It's the difference between being a benevolent philanthropist, making the world a better place, and being a Bond villain, you know? Like, ha ha ha, Mr. Bond. Before you die, let me show you my genuine Tyrannosaurus fossil that I am keeping away from the scientists so that no one can learn from it or appreciate it apart from me, you know? Yeah. Anyway. Now you want to replica UberWorks?
We've got a big sauropod thigh bone down there, big femur. And parts of that are real, yeah. From Hanksville, Utah. I'm gonna be driving past there in just a few days.
They're young on the beach. Yeah.
Very cool. And you can see there are parts of this that are broken off, like the pubes right there. That's snapped, broken. Wonder what happened. That might be plaster anyway, but still. You know, one of the caudal chevrons is broken off right there, and you can see the metal rod coming out. Yeah, it's a very old-fashioned way of mounting a skeleton like this. I'd love to see these mounted, you know, in an upright, sprightly, modern posture. But, I don't know. And then there's a young Allosaurus right there, it looks like. Very cool.
You want to say hello to this Apatosaurus right here? Look at that. Oh. What do you think of Diplodocid sauropods, sweetie pie? You like them? You a fan? Ouch. Whoa, little baby Triceratops! My goodness, I've never seen these before. These are brand new. Oh man, they're so tiny. I'm being mobbed by them right now. Stegosaurus. Stegosaurus and Ceratosaurus are, they were what we call coeval. So they lived at the same time and the same place in the Morrison biota, this kind of series of ecosystems that's preserved in the Morrison Formation. So Stegosaurus and Ceratosaurus would have encountered one another. They would have lived side by side. In fact, you could say...
And they were roommates.
Oh my god, they were roommates.
Yeah, maybe not quite roommates, but they definitely...
5 meters high at the shoulder, roaming Eurasia from Romania to China at the end of the Oligocene epoch, long after...
How those giant mammals, look how cute they are. Oh my... Just adorable. Just look, we want to pinch its little perissodactyl cheeks right there. Paraceratherium. I mean, that's cute, you know? Yeah, the largest mammal to ever walk the earth. Yeah, a pocket pet. There you go, Orchestran. Yeah. And Little Pig Pony says, I just got off work, now I'm off for the next 4 days. Well...
Watch out, Fisher, you're real close to them.
Oh. Was there anything put in that scoop? Ethan.
I don't believe so.
Okay.
No frags or anything. Nice.
Alright.
Nice.
Some progress there. If anybody at home has got a Prius and they want to be able to take it off-road, look up Prius Off-Road. There's a company in Chico, California, where they produce these lift kits for them. So it gives you just enough ground clearance where you won't scrape when you're going over rough terrain and stuff, and it allows you to put larger tires on it. So I'd recommend that. Yeah. Chat, there's very important parts of likely a brand new dinosaur in this white blob right here. That's like a good feeling. I love that feeling, like when
Let's go, boys.
Yeah.
That was weak. Come on, man. Come on, man. That was weak. Come on, man. Hit me. Yeah, let's go.
If you're looking for like a comprehensive like encyclopedia about dinosaurs, you can't get much better than Thomas Holtz's, I think, 2007 book, Dinosaurs, the most complete, up-to-date guide for people of all ages, or something like that. It's a green book. Holtz, Holtz is the author. It's a little out of date at this point, but it's really good. Still holds up in a lot of ways. If you're looking for more of a book to read cover to cover, I'd really recommend the writings of Michael Novacek. He's mostly a mammal paleontologist. I think he might still be curator of paleontology at the American Museum of Natural History in New York City. But his kind of fieldwork autobiography from like 2002, I think, called Time Traveler. And Atlas Bird says, when did we realize that birds were dinosaurs? So it depends who you're talking about. Some paleontologists realized this very early on. And for others, it took a lot longer. But it was really like the mid-1990s that it was a done deal. It was clinched. Because we started finding fossilized feathers on dinosaurs. And it's like, oh, throw in the towel. That's it. All the people who are saying that birds evolved from some sort of crocodile-like ancestor and that dinosaurs were not very bird-like or whatever, it's like, nope, back it up. The evidence shows, the fossils themselves show birds evolved from dinosaurs. Well, hello, everybody. Welcome back to Paleontologizing. It's so good to have all of you here today. Happy Wednesday.
It is September 10th, 2025. We're gonna have a good stream today. I was gone yesterday. I feel like it's been a long time since we've missed a Tuesday stream, but I had a very good reason for that. I went and gave a seminar talk at Berkeley before the Department of Integrative Biology and the University of California Museum of Paleontology. And I'd say it went pretty well. I'll talk about that in a little bit, but apologies for being gone yesterday. I'd say it was worth it, even though I missed all of you. Anywho, we have got a ton of fossil news to cover today, as the title would suggest. We've got new species of coelacanth. We've got new species of sea turtle that don't actually fit into this phylogeny here, which is very, very interesting. We've got a new lizard discovery that kind of shows potentially what's going on with the early evolution of squamates, which is really fascinating stuff. We've got a new paper on Solnhofen pterosaurs, and got some new stuff on sharks as well. So there's a lot to cover today. Holy cow. We'll get into it pretty soon here. And Sammy Keen, thank you for the 21 months of support. Hey, I really appreciate that. Holy cow. Thank you, Sammy Keen, for the continued support. 21 months is a long time, and that it's because of generous supporters like you that I can continue to do this full time. This, believe it or not, is my full-time job, and that's only because of good folks like you, so thank you for making that possible. Thank you for supporting my mission of science outreach and education. And hello, Minnie Pie. We're already getting a visit from one of the landlords here. Hello, Minnie. How are you doing? You having a good day so far? Yeah? It was a little bit rainy this morning. A little bit wet outside. I think Minnie Pie really enjoyed that. She doesn't go outside. There's a, like an enclosed area, so you can't prey on other animals and they can't prey on you, huh? Yeah, that's the way it should be, in my opinion. You still get fresh air? Lucky cat. Anyway, if anybody's here for the very first time, shoot, let me introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here on Twitch trying to do some good old-fashioned science outreach. So, when I'm not out in the field, which I will be starting as soon as next week. I think next Saturday might be our next stream from the field. I'll be out there in Utah for about 2 weeks, digging up some dinosaurs, collecting data, and streaming whenever I can, trying to give you an inside peek into how paleontology is done in the field, how we collect specimens, how we do our work when we're out there in the middle of nowhere, out in the Badlands. It's going to be a ton of fun. But when I'm not out on the field, I'm usually here in my office in beautiful sunny San Francisco Bay Area, California. This is where we go over new scientific papers, discuss new discoveries in fossil science. We sometimes interview other paleontologists remotely, like we did on Monday with Jake Newman Martin from Australia, talking about his new paper. It was a ton of fun. Yeah, and we do a lot of Q&A. The whole point of these broadcasts is to bring fossil science to you, to give you an inside peek into how all of this works, why it's important. It's what this is all about, you know? Oh, that, and also, well, these visits from the landlords like this. How are you doing, Minnie Pie? You having a good day so far? You pushing my camera around? Yeah, there we go. Let's get some treats for you, huh? Would you like that? Would you like that? I think so. Yeah. Anywho, it's really good to see everybody there in the chat. I missed you all. It's good to be back, and I'm glad you're back too. Yeah. Hi. Yeah. Let's brush you a little bit first, shall we? Is that okay? Is that okay? You got all this loose hair. I can see it on you. You think, can I? Yeah? I'll take that as a yes. Oh, there we go. Yeah. Excellent. Hang on, don't get too worked up now. I don't want you clawing me or biting me, huh? Yeah. You know, sometimes you get a little too excited. Yeah. All right, let's get you paid, huh? There we go. Whoa, look at all those. Look at that. It's been a few days since Mini Pie's had these. She's glad you're back streaming too. This is true, Charlie's Dragon. This is true. I'm glad as well. It was a little bit nice to have something of a day off yesterday. Especially because it's been, well, shoot. It's been actually a little bit overcast and rainy here in the San Francisco Bay Area for the past couple days, and well, shoot, that's kind of out of the ordinary. So it's been really nice. I've been enjoying it. But yeah, and here, let's take a look at a live cam view from the Berkeley Hills. That's not working. There we are. Yeah. So, okay. It's moderately sunny today, which is nice. This is beautiful San Francisco Bay right here. Berkeley and Emeryville here. There is Yerba Buena Island, San Francisco off in the distance. There's the Golden Gate Bridge across the Golden Gate Strait, the entrance to the Pacific Ocean. Yeah. It's been really nice having I don't know, I've missed the kind of the fog and the overcast and the rain and the drizzle and stuff. We haven't been getting a lot of that lately, so it's been nice. And it was nice to be able to enjoy some of that yesterday and not be cooped up inside streaming for the afternoon. It's nice to take a break every once in a while, you know? And, yeah, my talk went really well. I didn't end up recording it or streaming it. I didn't actually even get any photos. But, I'll say it was very well received. What's this?
Aren't you the man who told me to live every week like it's Shark Week?
That's good advice.
And nothing's impossible except for dinosaurs.
That's bad advice.
Don't give up on life, sir.
I need to send you an important email tomorrow.
And Dyson Dinosaur, thank you for the 27 months of support. Holy cow. Really appreciate that, Filippo. That is dinosaur paleontologist Filippo Bertoso there in the chat. How you doing, Filippo? Important email tomorrow. All right. Very nice. Cool. I hope you've been doing well, Filippo. It's good to see you. I'm going to be leaving for the field next week. So, yeah, send me that email when you can. I don't know what it is, but if it's something that'll be coming up soon, when exactly? I'll probably be leaving next Wednesday or possibly Thursday. Because the 19th, which is Friday, will be when I'll be showing up there to meet Josh Lively and his crew from his museum, and we'll be setting up camp on the 19th. So yeah. Yeah, Monday is an important day. Oh, well. Okay. Good to know. Very cool. Excellent. Here.
I'm here to applaud the work of vertebrate paleontologists.
Well, thank you. Astrophysica for the follow. Welcome to Paleontologizing. It's good to have you here. So we didn't stream yesterday. Today is the 10th. I will be starting stream late tomorrow. But I have an important meeting down in Monterey, California. I'll tell you about that after it happens. Very excited. It's related to leatherback turtles. Can't wait. No promises. I might end up doing a makeup stream on Saturday the 13th. We shall see. And when I say makeup stream, I don't mean applying makeup or anything like that. I mean, we'll be making up for our stream that we missed yesterday, because I was giving that seminar talk in Berkeley. We might be doing a makeup stream on Saturday the 13th. We'll see. No promises. yeah. No eyeshadow? Nope, Kennedy. No. And, yeah. The first thing that came to mind was face makeup. You get that Petrodactylus. Yeah. Fair. Sorry to disappoint. Anywho, I'll be back out in the field. Hopefully streaming starting on the 20th. So this will be, in about a week and a half. So yeah, I may or may not stream on Wednesday. In fact, yeah, I don't know. We'll see. We'll figure that out. But yeah. Danny drag makeup stream when I don't know if that would go particularly well, Lordy. You've got a beard. Like, how do you cover that up? Can you get a bald cap for your face? I don't know. Anywho. Oh, that's interesting, Kennedy. No, there is a gal on Twitter who did that. Shoot, what was her name? I'm not on Twitter anymore, but... Oh, she's on Blue Sky as well. And she's a paleontologist. Here she is, Lisa Buckley. Oh, she calls it bird glamour. Here we go. Yeah. She says, in my old life, I was a vertebrate paleontologist who studied fossilized bird and dinosaur footprints. Now I work as a remote medical scribe for a podiatry clinic. I do bird glamour, a SciComm project where I create makeup looks based on birds and other critters. So there's a red-throated loon right there. Cool stuff. I'll give you a link to her page if you want to follow her. But, yeah, pretty neat. I always enjoy seeing these. This is not the sort of thing that I do. But, there you go. Yeah, pretty neat. Yeah. You look great with no makeup. Thank you, Lordy. Appreciate that. Anyway. Yeah. Yeah, good stuff. And, yeah, speaking of Blue Sky, exactly, Claire. You took the words right out of my mouth. Let's do a quick post to Blue Sky real quick. Let's see if that screenshot turned out okay. That'll work. Yeah. Doesn't have to be perfect. Okay. There we go. Save as. Beautiful. There we are. There's so much paleontology news to cover today. New coelacanth species. New insights into shark evolution. New ancestral lizards. New Solnhofen pterosaur fossils. Oh, and even a new fossil sea turtle. Join us to discuss at twitch.tv/paleontologizing. Paleontologizing. Good, I spelled it correctly. Alright. Screenshot of me in my office. With a papercraft 3D coelacanth behind me on the wall, as well as a 3D printed fossil sea turtle hind flipper. That's Archelon, but when you say Archelon, people expect it to be huge, so I'll just say fossil sea turtle flipper. As well as framed phylogenies. Phylogenies are evolutionary family trees, for anybody who's hearing that term for the first time. Framed phylogenies of sharks, sea turtles, and framed figures, coelacanths, tuatara, I'll say lepidosaurs actually. And pterosaurs, there we go. And save. Let's post it.
Hold on to your butts.
Post. There we go. Lovely. And there's a link in the chat if you'd like to engage with that post. Excellent. And is that the turtle that was in a museum in Australia? I think it was in somewhere in Europe. It might have been Sweden, Benji. We'll take a look. In fact, let's see here. I've got that right over here. There's that sea turtle paper. Snow in Switzerland. There we go. Swiss Museum. We'll take a look at that in a little bit. Yeah. And Vexy says coelacanths aren't dinosaurs, right? No, they are 1000% not dinosaurs. They're not even tetrapods. They're here. You know what? Actually, I can show you now. We've got this, I show this all the time. Nice little kind of cheat sheet on what is a dinosaur and what isn't. Coelacanths aren't even on this tree. They're basal to amniotes. They're basal to tetrapods. But dinosaurs are every creature that evolved from that first dinosaur, that first ancestral dinosaur. Something similar to like Eoraptor or Pampodromius or something like that. So dinosaurs begin right there. If it didn't evolve from this animal right here, it is not a dinosaur. And I've been using this so often. I've been using this image for years and years. This is a poster that you can actually order from 252mya.com. They do all kinds of cool stuff. And I felt kind of bad for never actually having purchased this until now. Let me go get it and I'll show you. The frame arrived yesterday. Check that out right there. We'll be putting this up in the background at some point. But, yeah, I wanted to support the people who actually put this together because, again, I've really benefited from their work and they deserve to get paid for it, 1,000,000%. So there it is. Yeah. Pretty happy about that. Yeah. Very nice. So anyway, coelacanths are a kind of sarcopterygian fish, as are tetrapods, but let me show you rather than just telling. Let's take a look. Go to our tree of life right here. Anyway, so yeah, like, as Charlie's Dragon was saying, yeah, dinosaurs doesn't just mean prehistoric looking thing, it's a specific group of reptiles, just like mammals is a specific group of animals. Exactly, yeah. The way that we as scientists classify living things is based on how they're actually related to one another. So, when we're talking about taxonomy, when we're talking about how to classify living things, what we're talking about is, it's not some arbitrary made-up thing. It's pointing to a real, actual, natural, objective reality. And we're just trying to figure out that reality. That reality is common ancestry. It's the tree of life, as we call it. So, let's jump to animals on our tree of life here. This is the clade Metazoa. A clade is a group of organisms, living things, that all share a common ancestor.
All brontosauruses are thin at one end, much thicker in the middle, and then thin again at the far end.
Figuring out
How's that for some reality there, Diagonal? Yes, indeed. Thank you for the 55 months of support. Really appreciate that. Good stuff. I love that clip. Yeah. Anyway, this is what we're trying to do as scientists, is trying to figure out how the world works, trying to figure out what's what. Separate fact from fiction. Determine how nature really works. So animals, it's 1.4 million species, just logged here on this tree. All of these creatures shared a common ancestor. That's why they're related to one another. When we say they're related, we mean that quite literally. In the same way that you are related to your siblings, if you have siblings, or your cousins, if you have cousins. You're related to your parents because they birthed you. You know, you're directly related to them. Your DNA is going to be pretty similar to your parents because that's where you got it from. It's the same with animals, too, or any organism. As creatures survive and reproduce, they have offspring. Those offspring are a little bit different from their parents. If they have offspring, it's a little bit different from them. It's that kind of variation that evolution works on. So different lineages can split. You can get diversity that starts to evolve. So animals are one big branch on the tree of life, but we can zoom back out until we get to the origin of all life. Because as far as we know, all critters on our planet, plants, animals, protists, fungi, they all evolved from a single common ancestor.
Speaking of dinosaurs, did you realize
GM, thank you.
chickens were a lot like little dinosaurs with feathers? I didn't.
That's true.
So I read a book called The Dinosaur Chicken Conspiracy. Apparently, the poultry farmers don't want us to know anything about it, so they've hushed it up.
Unfortunate. Thank you for the 13 months there. GM, I appreciate the ongoing support. Excellent. Good stuff. Anyway, let's jump from all life over to coelacanths. Given that's what prompted this conversation here. There's only one genus of coelacanth still alive today. There we go. These critters. There's the... this is the West Indian Ocean coelacanth, and then we have the Sulawesi coelacanth. They're both threatened with extinction right now. But these are a kind of lobe-finned fish. And this group, Sarcopterygia, actually includes not just lobe-finned fish like the coelacanths. When we say lobe-finned, we mean that, these guys, their fins are kind of fleshy like this, and they actually have bones inside. This is where tetrapods, which are vertebrate animals that ancestrally they came up onto the land, that's where they got those limb bones from. These are modified fin bones. So anyway, we have this in coelacanths. Coelacanths are part of this group, Sarcopterygii. This group includes amphibians and reptiles, like this snake and this caecilian and this penguin. Actually, are caecilians amphibians or are they reptiles? I'm forgetting now. They're amphibians. Anyway, penguins and buntings are both kinds of birds, which are a kind of reptile, which are a kind of amniote, which are a kind of Sarcopterygian, a kind of lobe-finned fish. The tetrapods, all of these creatures, excluding the coelacanths, they are a kind of lobe-finned fish. So yeah. Anyhow. We'll be getting into coelacanths in a little bit, and I'll be talking about why these critters are so incredibly cool, and why I love talking about them. But yeah. Anywho. And new? Yeah, we've got several new species of coelacanth that I think have just been published on. I haven't had a chance to read the paper yet, but yeah. I've been so busy lately getting ready for this talk yesterday in Berkeley that, yeah, I don't know. I'd been putting off a lot of other things getting this talk together. And I was a little nervous. In fact, let's talk about that for a minute. I gave a talk at the University of California Museum of Paleontology. And this was a big deal for me. This is just down the road for me in Berkeley. There's the big T-Rex skeleton outside. UCMP is where I got my start as a paleontologist. When I was in high school, I volunteered at the University of California Museum of Paleontology. This is where I first got to hang out with paleontologists, to participate in fossil curation and research and outreach. It was a big deal for me. It was a really big deal. And I started going to these seminar talks, what we call fossil coffee, which sometimes happen on Tuesday mornings during the semester. I started going to those in like 2007 when I was a bright-eyed, bushy-tailed high school student. So this is a seminar talk, which means that it's an ongoing series of talks with a different speaker each week, sometimes multiple speakers. And these might be students or professors there at the university. They might be visiting scholars. They might be museum curators from other museums who have traveled to Berkeley to do some research there, and then they give a kind of a guest lecture. That's essentially what the seminar series is. It's a series of guest lectures like that. And this year, I decided, why don't I sign up to give a talk? A talk about my science outreach here on Twitch. And, yeah, here we go. This is the title right here. Title slide. I was a little bit nervous about this, honestly, because I'd been attending these seminars, these fossil coffee talks like this, basically since I was a kid, you know? Since I was like 15, maybe 14 years old. And finally, like, getting the chance to be a speaker at this was a big deal for me. You know? And being able to present on what I do for a living, streaming here on Twitch, to a group of people that I have tremendous respect and admiration for. These are not just my colleagues, these are people that I really look up to. You know, veteran paleontologists, researchers, curators, professors, and then a bunch of graduate students and undergraduates too. So to be able to talk about what I do here on Twitch, talk about the outreach that we do, the fundraising, the field work, all of this stuff. This is what I've been doing for the past 5 years, is streaming here on Twitch, doing science outreach full time. To be able to present that to my colleagues, people I have tremendous respect for, and have them listen intently to this, it was something I was nervous about. But they really liked it. The talk was very well received, and I'm excited that I might be doing some collaborative stuff with the Museum of Paleontology on stream in the coming months and years, hopefully. I've got a meeting about this next week that I'm very excited about, and yeah. So, are they all getting Twitch accounts? I don't think so, Claire, but we might be using this platform to help promote some work at UCMP in the future. Maybe do some fundraising. I'm not sure what's in the pipeline right now. We've got to discuss that. I've got a meeting next week. But it felt really good to be able to share this with my colleagues there. I'm very proud. Again, this is something I was nervous about. So anyway, they really like the talk. And I'm thinking about if we do stream on Saturday, if we do a special bonus stream on Saturday, then I might give this talk for all of you. And I think that would be cool. Just do like a little presentation here. We'll see. Anywho, it was really good. I'm very proud of how that went. And again, I missed all of you. Didn't stream yesterday. There was a good reason for it. I wouldn't miss stream for just anything. This was good. Yeah. And Dyson Dinosaur. Oh, Filippo, where and when was this talk? It was yesterday at Berkeley at the seminar at UCMP. So at the University of California Museum of Paleontology in Berkeley, California. Here's the T-Rex skeleton outside the museum there. There we go. UCMP. It was great. Yeah. Yeah. It's presenting on my outreach here on Twitch, you know? And it was nice. I feel like I won't be nearly as nervous the next time that I want to present at something like this. We've broken that seal. It's, or, there we go. To use a video game analogy, I know a handful of people on Twitch enjoy video games. It's kind of like in a video game where you visit a new place and then suddenly it like unlocks that part of the, you call it a map, right? It unlocks that part of the map. It felt like that. I gave that first talk. I could do this now. Yeah. PT Studio says video games on Twitch must be a niche. I think so. Yeah, but you know, I'm sure there's some people on Twitch that enjoy video games. It's not just science outreach, right? Anyhow, yeah. Nelf says Saturday speech would be awesome if it works out. Well, it wouldn't be a speech, but I'd go through the talk and you know, it'd be interactive. And that's actually one of the points that I made while I was giving this presentation in person yesterday in Berkeley. As I said, you know, I know our normal format is for the speaker to show all of the slides and talk about everything uninterrupted, and then there's questions and answers at the end. I said, I don't want to do that. I said, I'm not used to giving prepared remarks. This isn't something I'm accustomed to. It's a little bit outside of my comfort zone. So in order to make things a little bit easier on me, I said, if you have a question, a remark, something you're curious about, a comment, whatever, don't wait until the end. Raise your hand, or if it seems appropriate, just blurt out. It's okay to interrupt a little bit. Because I want this to be more of a conversation than a lecture, you know? And people did, and it went well. I was really happy that I decided to do that, because it did make things go more smoothly for me, for sure. Yeah. So anyhow, yeah. And, well, E to the 2i Pi, thank you for the raid. Well. How's it going? Welcome to Paleontologizing, E to the 2i Pi. It's great to have you here. Thanks for joining us. What's shaking? Yeah. Poison Mouse, thank you for the follow there.
Prehistoric horrors.
Good stuff. And Kevin does chemistry. Hey, welcome to Paleontologizing. It's great to have you here. You do chemistry? That's awesome. I do paleontology. This is what I do. In fact, here, let me show you. I had this little video during the talk, but That's odd. It seems to have gone away. Where is my channel trailer? Here we go. I played this during the talk to introduce myself. Maybe about a quarter of the way through the talk after I did the intro. But yeah, here's a little intro for anybody who might be new. Check it out. And actually here, gotta set this up for viewing properly. There we are.
My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs.
A limb bone from a new duck-billed dinosaur.
I invite you to tune in and experience the adventure of fossil science. There we go. Yeah, so that's what I'm all about. Welcome to Paleontologizing. Him and Does Chemistry says, but we love the beakers and the white lab coat stuff too. I guess, but I'm also trying to make the point that... Here, let's run a little exercise. I hesitate to call it an experiment. Let's call it an exercise. Let's do a Google image search for scientist. And what do we see? Lab coat. Lab coat. Lab coats. Lab coat. Lab coat. Lab coat. Lab coat. Lab coat. Just lab coats all over the place. I do appreciate that, and I feel like maybe Google has done this on purpose. There's not such an emphasis on, like, middle-aged white men as scientists. We've got some younger people, we've got people of color, we've got people from different backgrounds, different genders. It's not just all middle-aged white men. But, yeah. I am trying to push back against the white lab coat thing just a little bit. I do own a white lab coat. I've never used it for science. I only ever use it when I'm doing messy stuff like screen printing. In fact, that's the only time I've ever worn a lab coat in my life, I think. Yeah. Even in chemistry class. Chemistry lab. But yeah, anyway. There's many, many different kinds of science. And it's not all done in a laboratory. Much of it is done out in the field, collecting specimens, gathering data, prospecting for fossils in my case, you know? So yeah. Yeah. I always wear mine when I do math, really? Pui Utica? Well, if it helps you math more effectively, then yeah. Who am I to judge? Yeah. Yeah, make sure those messy numbers don't get all over. Exactly, Claire. Yeah, yeah. Anywho, yeah. And Trek Nerd says, "I got a science is for everyone feel from the video." Oh, good. That's what I was hoping for. Yeah. And Dark Muppeteer says, "I love that the closed captioning changed beakers to beers." I should probably go through and manually type out those closed captions. Yeah, I don't know. It's given that field work and that clip was in Utah, I can't say this for I can't say this for certain, but without getting in trouble necessarily. But yeah, it's some field sites there might be way more beers than there are beakers. And that may have been true in that case too. Oh no, it certainly wasn't the case there in the great state of Utah. Everyone knows that's a dry state. There's no alcohol in the entire state. Anywho. But yeah. And Jerry Andrews says, love the coelacanth. Thank you. We're going to be talking about coelacanths today in just a little bit. There's several new species of fossil coelacanth that were just described. But, yeah, I read a book about them in high school. I think I might have that book, actually. Not your exact copy, but... Here. I think it might be... Was it Old Forelegs? Classic piece of science writing by J.L.B. Smith. Yeah, this is the annotated version, which is really nice. Yeah, so the updated story of the coelacanth. So that's probably the one. Again, this is a classic right here. Yeah. So that one I think was copyrighted in the 60s? Let's check. Because the original... No, even earlier. There we go. The original Old Forelegs, 1957 right there. Nice. Yeah. So this is that book, just with annotations. So again, here is the original text, and then there's notes on the sides. Updates, thoughts from modern coelacanth researchers. It's really good stuff. I highly recommend this book if you want to learn more about coelacanths. And there's another one too that I can recommend to you. This is published, I think, in the 2000s, and it reads like an adventure novel. It's phenomenal. A Fish Caught in Time by Samantha Weinberg. Really can't recommend this highly enough. It's a phenomenal book. Except for the cover. This doesn't even look like a coelacanth right here. They got the head completely wrong. It's like a trout or something. But anyway, yeah. The tail looks like a coelacanth, but they messed up the head. Anyway, so let's cover that up. Phenomenal book. Really, really good. Can't recommend it highly enough. Yeah. Anyhow. And need more bookcases? Yeah, I don't have any space for more bookcases, Zool. At least not over here. Yeah. I don't want to cover up this area with bookcases. Yeah, I wouldn't have room for specimens and visual aids and accoutrements like that, you know? Anyhow. Yeah. Anyhow, good stuff. Thank you so much, E to the Two-Eyed Pie, for the raid. I hope you had an excellent stream. Can we get another shout-out for E to the Two-Eyed Pie? What were you working on, if you're still here? I realize you've just finished your stream, so if you've got to go rest, do some chores, or go exercise or something, then, yeah, I totally understand. And doing some just chatting, very nice. Very, very cool. Yeah. And Zul says, time to go Mr. Beast route and invest in a streaming warehouse. That'd be nice, but I also like streaming from home, you know? I don't want to have to go walk to a warehouse. I couldn't abide driving to a warehouse. I don't like driving if I can help it. Yeah. I mean, like, moving without exercising is like, it's like a missed opportunity. And yeah, I'm not made of money. Exactly, Crimson Carnotaurus. Yeah. I'm a renter here, you know? I don't own this place. But yeah, you've seen my landlords. Shoot, one of them just showed up a few minutes ago. Yeah. And well-established authors who have no say. I think that's probably what happened there, Kennedy. Yeah. Yeah. Anyhow, it's good to have everybody here. As I was saying, that my talk yesterday went really, really well over at the university. And, yeah, maybe since we missed yesterday's stream time because of that, dare I say it was worth it. But we might do a stream to make up for that on Saturday. We'll see. And maybe I'll give that same talk to all of you if you would be interested. But yeah. Anyway, we've got a lot of cool stuff to cover today. A ton of fossil news. We'll get into that in just a few minutes, but yeah, there was a little bit of sad news in the world of paleontology too that I should also mention. Mark Norell is kind of a, almost an elder statesman in vertebrate paleontology, just passed away. I think this was yesterday the news broke. And yeah, we knew that Mark had been suffering from ill health for a while, for a few years now. Yeah, here he is, right here in a video.
Interestingly enough, when I came here to the museum, I'd never worked on dinosaurs before. All of my previous work had been on fossil lizards and on fossil crocodiles and fossil mammals and that kind of thing. But one of the first questions they asked me, they said, if we hire you, will you work on dinosaurs? You know, it really combines two of the things that I love most in the world. And one is being a scientist, and the other one is the ability to go traveling. Technology really facilitates shorter field trips these days. In many cases, in these countries, they didn't even have fax machines, so you were lucky if they had a teletype. So you were sending snail mail back and forth. You know, you'd get to the airport, you had no idea who was meeting you or if anybody was. It was just very, very difficult to communicate internationally. I mean, the world's really changed over the last couple of decades in planning and
And so this video is from 13 years ago, by the way, Hamster Rain. Yeah, so this would be around the time that I first met Mark Norell, actually. I met him at the Society of Vertebrate Paleontology meeting in 2013. It was in Los Angeles that year. It was my first SVP. And yeah, I have a little bit of a story about that. I wish I had this thing at the ready. I've been so busy lately that I haven't had time to go find it. But I have a keepsake from that, from Mark Norell, actually.
expedition. I mean, today, you know, I can just sit down in my office. I can have, on one screen, I can have my colleagues, you know, just Skyping in from China. On the other screen, we can have, you know, Google Maps up, and we can say, okay, like, you know, here's where we were last year. We can put this filter on Google Maps to, like, you know, look at different rock types and that kind of stuff. Because here's where we want to go next and next and next. The greatest fossil discoveries are not the ones which you expect to find. It's the kind of stuff that you would never dream an animal, you would find something like that. There's been a couple of times, especially in the Mongolia expeditions, which was just really special. In 1993, when I found the dinosaur egg, and that had the embryo on the inside of it, because, you know, it's the old story that there was animals which were collected by people from this institution back in the 20s that they found.
This institution is the American Museum of Natural History in New York. It's just in, like, Central Park West. It's one of the most famous museums in the world. And Mark Norell, I think, I'm trying to remember his exact title. I don't know if he was director of the museum or if he was curator of paleontology, but he helped run this institution. So it's you know, one of the premier positions in one of the world's foremost museums. So again, elder statesman in the field. And he was curator emeritus, fossil amphibians, reptiles, and birds, division of paleontology. Thank you, Claire. Yeah.
An oviraptor, a type of carnivorous dinosaur, next to a nest of eggs, and they'd interpreted those eggs as Protoceratops eggs, which is a small herbivorous dinosaur. They called it oviraptor because they felt the animal had died or perished while it was feeding on that nest.
And so this is actually something that that I produced some art for. Here, Denver Fowler tells this story really nicely. Let me find that clip, and then we'll let Mark continue the story there. There we go. So this is me and my old mentor from Berkeley, or excuse me, from Bozeman, Montana. Denver Fowler. And this is an eggs exhibit that he put together. I helped out with this. I designed these placards and stuff like that for his museum back in 2017. So I created a template that he could just kind of plug and play so that anytime he wanted to put up a new exhibit, this is like, vital information about each of these specimens. And so, it had the text and the font and the colors and the time scale and everything just ready to go. So it was, plug and play.
Oh yeah. So
yeah.
Yeah, this is. I think the first one you made was this one.
I think so. Yeah.
Mainly because I know because this is the one where I haven't fixed all of the different bits. I don't mean fixed. I mean like set in cement. Like anyway.
Yeah.
Yeah. So this is the plan for these panels. Like I told Danny, I think that there's too much of the basic information often just gets strung out and written into long sentences, like what date it is from, what formation it's from, how big it was, and really all that information should be just in a little fact box, and then the text in these is supposed to be information that's unique or new. So little facts and things.
So yeah, that was during that summer in 2017 when we were waiting for our permits. I spent a couple days just designing a template like this that would be plug and play. So I chose a font and try to pick colors that would work well with the rest of the museum, and then designed this right here and got the colors all exactly right according to geological maps and everything. And yeah, so I'm really pleased that you've been able to run with that and you're still using it. That feels like it made a real contribution there.
I've adapted it a number of times, different sizes. All these boxes look about the same size, but if they're close to the front or if they're at the back, there's 20% difference.
Yeah.
So they look more or less the same to you, but they're actually all different sizes.
This is smart. This is the sort of thing that Denver thinks about. Denver's also an excellent curator, just like Mark Norell. In fact, we've actually talked about some of the stuff that we've learned from AM&H in the past. Some things that we didn't like, but mostly things that we've thought that museum did really well.
It's really boring, that kind of thing. It's almost as boring as different light bulbs, but
it's important though.
Once you start putting these things together,
No, the nuts and bolts of this sort of thing. This is important, and I think it's interesting. I don't know if there's anybody that would think that was interesting. It might be a Twitch audience. You folks appreciate details. You appreciate how things work. That's one of the things that I really like about Twitch and this audience is that, yeah, I don't know. You get it,
For the different scaling and sizes of panels.
Definitely, yeah. Neat. And I recognize that piece of artwork there too.
Here we go. This is why I pulled this clip up. This is what Mark Norell was talking about.
Was that City Patty, I think? Yeah, or Overaptor, either one. But yeah.
I tell people that this is my favorite display in the museum.
This one?
Yeah, and these days maybe it's one of the newer ones, but this was at the time my favorite. It's because it shows the process of science. Here it is.
Yeah.
Back in the 1920s, the American Museum went to New York. They found dinosaur
From New York, they went to Mongolia, is what Denver said. That's what he meant.
eggs, and they found baby dinosaurs, these Protoceratops babies, and they said, "Oh my God, Brent, we've got nests of Protoceratops," and so when this museum.
So Protoceratops is this horned dinosaur. It's a ceratopsian. It didn't actually have horns, but it's a member of Ceratopsia. So we call it a horned dinosaur because that's what we call that group. Here's a Protoceratops skull 3D printed right here. So this is the animal. It's about the size of
that gives
very large dog or something.
It's very quirky, fortuitous, chancy
Lady
character.
Lalian.
We are literally here only because of the good fortune of dinosaur extinction.
It's true, and I'm here thanks to the good fortune of your support, Lady Lalian. Thank you so much for the 7 months right there. Thanks for keeping me here on the air. Appreciate you. Yeah. So yeah, Protoceratops. So that the folks from AM&H who went to Mongolia in the 20s, they found all these eggs. There are Protoceratops all over the place there. This is the most common dinosaur that they found. So when they started finding nests full of eggs, they thought, well, shoot, they have to be Protoceratops eggs, right? It just makes sense. These dinosaurs are super common. Then they start finding these eggs. Just by the numbers, they have to be Protoceratops eggs, right? Yeah.
Brent, we've got nests of Protoceratops, and so when this museum opened in 1992, well, in 1993, this is one of the models that they had, and it's a bunch of baby Protoceratops and a bunch of those eggs that were found by the American Museum. And the same year that this model was made, the American Museum had been back to Mongolia, and they'd found more of these eggs, of course, and they cracked a few open, and inside they found oviraptor embryos.
Yeah, not Protoceratops.
Not Protoceratops.
Yeah. Yep.
And of course, back in the 1920s, they'd found an oviraptor standing on top of these eggs, and they thought the oviraptor was stealing the eggs of the Protoceratops, so they called it egg thief oviraptor. And now we realize that the oviraptor was actually protecting its nest, and that these are oviraptor eggs. So I tell kids, it's like, if this model shows anything at all, it shows a bunch of baby Protoceratops smashing up an oviraptor nest out of pure spite. And so that's why they look so happy. So this will learn you. But it shows the process of science. And
Yeah.
it shows that, it was a good hypothesis. You had baby dinosaurs, you had eggs. Why aren't they both related? But it turned out that they weren't.
Anywho, that's a really cool story. Here's a link to this VOD if you want to take a look at that. This is one of the VODs that I'm most proud of, being able to go all the way to North Dakota and take a tour of this museum, see specimens that I discovered on display there in the museum. Because I used to work with Denver. We would go out and do field work together. He was my mentor for a while when I was in Montana. But I helped out with this museum. I helped design some of the displays and some of the placards, and I found some of the specimens and stuff like that. So this was a ton of fun. We were here last February. This was earlier this year. Not last February. This past February. February of 2025. Anywho, that story about the Protoceratops eggs that turned out not to be Protoceratops eggs. This is what Mark Norell is talking about here.
As Protoceratops eggs, which is a small herbivorous dinosaur. They called it oviraptor because they felt the animal had died or perished while it was feeding on that nest. And because oviraptor means egg stealer. When I found the embryo, and I could clearly see that it was not a Protoceratops embryo, it was the embryo of a carnivorous
Oh, and
dinosaur.
very cool, Alexander Morrison.
That was a
Nice.
big thing. I mean, that was a very, very exciting moment. The greatest fossil discoveries are not the ones which you expect to find. It's the kind of stuff that you would never dream an animal, you would find something like that. And one of those was when I found that the oviraptor sitting on top of the nest of eggs, brooding it.
So Mark Norell found that. You could say he was the guy who finally exonerated oviraptor. This dastardly egg thief wasn't an egg thief at all. I'm sure in the vastness of time, while that species existed, I'm sure there was a Protoceratops here or there that had its eggs eaten by an oviraptor, sure. But that's not what oviraptor did on the regular. There's no reason, we don't have any direct evidence that oviraptor actually fed on eggs. Did they occasionally? Maybe. I don't know. But we don't have any reason to think that. We don't have any direct evidence of that now. And Mark Norell helped figure this out,
When we first started getting into the game, that it used to be this idea that there are birds and there's dinosaurs. The brooding oviraptor just showed that, well, here's another behavior that we think is stereotypical of modern birds, but has roots that are much deeper within non-bird dinosaur history. You've got to be ready to walk into the lab today, and if somebody's come up with something, just say, everything I've done earlier in my career is all garbage, it's all wrong, and move on.
Yep.
And that's a good thing.
There you go. Spoken like a true scientist. So this is a loss, Mark Norell passing away. A lot of us really looked up to him. I got to meet Mark Norell back in 2013 at SVP, and we had there's a tradition, it still goes on today, at the Society of Vertebrate Paleontology meeting. This is the big global meeting for paleontologists who study vertebrate animals with bones. So if you're a paleontologist who works on animals with bones, you're a vertebrate paleontologist. And SVP is like the one big conference every year. That's the big one. And in 2013, I was a young, enthusiastic undergraduate. This is my first big scientific conference, really excited about it. I flew from Montana to Los Angeles to be able to attend this. And yeah, I'd heard for years prior to this that there's a tradition on the last evening of SVP during the after party, basically. The conference is done as everyone has presented their research. There's been all kinds of learning and curiosity, questions, and everybody's just really jazzed about the science, and then we have a party at the end, the after party. And the tradition is at the after party, we exchange name tags. So everyone's had a name tag with their name on it and their institutional affiliation and everything. You've worn this for the whole conference prior to the after party, and then you trade. And the idea is you try and trade up to, a bigger name, somebody that's, I don't know, that everybody knows. And so I'd heard about this practice for years prior to this. When I was volunteering at UCMP during high school, people like Pat Holroyd would tell me stories. I'd ask her, like, Pat, why do you have all these name tags that aren't yours up on the wall? She goes, oh, well, we trade them at SVP. So I'd heard about this for a long time. And so as an ambitious young student, I decided, I'm going to get a big name. I'm going to be bold about this. For my first SVP, I want to go big, And so the after party starts, and I'm, walking around talking with colleagues and friends. And then a friend of mine, Brian Baziak, walks up to me, another guy from Museum of the Rockies. He worked in the laboratory there. And he says, hey, Danny, do you want to trade name tags? And I go, sure, Brian. Yeah. Brian's, older than me. He's got a full-time job in the museum. Like, yeah, sure. Also, he's a friend. Like, I'm not going to say no to him. And so I trade name tags with him, and then I'm walking around with Brian Baziak's name tag, and I walk up to Denver Fowler, who you just saw in that clip, my old mentor. And Denver says, we're talking for a minute. He looks at my name tag, and he goes, oh, no. This is not meant as a dig on Brian from my perspective, but it was intended this way from Denver. Denver goes, Danny, no, you traded down. Why did you do that? I said, I don't know. I was going to say no to Brian. He's like, you better remedy that. And so I'm like, okay, well, and I'm just scanning the dance floor at the after party, like Terminator vision, just. And then I see across the dance floor, there's Mark Norell. And he's standing there at a table with some colleagues talking. And I just beeline it over there. And when it seemed like a good moment to kind of insert myself to this situation, I saunter up to him and I start talking to him about alvarezsaurs. These are these really cool little dinosaurs with these cool hook-like hands. They've got one big thumb claw on each hand like this. And Mark Norell had published on one of these guys, maybe on several of them. But I think he was one of the authors on Shuvuia, which is a kind of alvarezsaur from Mongolia.
We have the Tradoon.
Legit salvage. Thank you for the 10 months of support. I appreciate that. Thank you. So yeah, it's like, here's my in. I'm talking to Mark Norell about alvarezsaurs because that's what I was presenting on this year. That year, 2013 at SVP. I was presenting on Trirarchuncus before we ever named or published on it. And yes, we're talking about that for a while, and then it was a nice little conversation I had with Mark Norell, and then at the end I'm like, hey, it's been great talking with you. Would you mind trading name tags real quick? And Mark, being a kind person, he says, yeah, sure, let's do that. So I hand him Brian's name tag. He hands me his. And I go walking back to my group of friends from Museum of the Rockies. Denver and Brian and Liz and a few other people are there. And they see me sauntering back and they see my name tag and they go, whoa! Especially Brian. Brian goes, does that mean Mark Norell is wearing my name tag right now? And I go, yeah. So I was, I don't know, that was pretty great. So yeah, it's certainly a loss. Mark Norell was a big name in our field. He did a lot of stuff. He made major contributions to dinosaur paleontology, to our understanding of dinosaurs, the relationship to birds. He helped run the American Museum of Natural History, their field program. He was one of the leaders of the expeditions out there in Mongolia. Mark did a lot of stuff, and his passing away yesterday is... it's a sad thing. It really is. We knew that he'd been ill for a few years. This would have been 2023 at SVP. He was awarded the highest honor that the Society of Vertebrate Paleontology can bestow, called the Romer-Simpson Medal, named after Alfred Sherwood Romer and George Gaylord Simpson. And let's see, I'm not sure if we have a list of Romer-Simpson medalists. But Mark Norell won this in, I think, 2023. Here's the Wikipedia article about Mark right there. There you go. Thank you, Claire. Yeah. And there's the Romer-Simpson medal. So, and I guess this hasn't been updated, but yeah, it must have been 2023 right there. Honors and distinctions. And I guess it's not there either. Anyway, I missed this SVP. It happened to be the same exact weekend as TwitchCon that year, so I didn't get to go to this one. But that was, I think, in Cleveland at the time. And yeah, it was a big deal, you know. The Romer-Simpson Medal, that is again kind of the highest honor that a paleontologist can receive. There is no Nobel Prize for paleontology. There should be, but there wasn't. There isn't. So that's as close as we get, is the Romer-Simpson Medal. Mark Norell won that in... it was deserved, you know? He's made tremendous contributions to the field of paleontology, so huge paleontologizing salute to Mark Norell. We've lost a major figure, a driving force in vertebrate paleontology. He's got a lot of achievements. I'm sure his family is proud of him, and I know we as vertebrate paleontologists in general we're going to miss him a lot. He's a good guy. So anywho, yeah, Golganek says he was also out in front of a lot of paleontology science communication. I remember Mark Norell being in a ton of dinosaur documentaries. Absolutely, yeah. Here we go. I bet you we can find him in this documentary here. Well, shoot, for one thing, we've definitely got him in several documentaries about digging up dinosaurs in Mongolia. Dinosaurs of the Gobi. Here we go. So he is definitely... in this one here.
Now your mind wanders.
That's him.
Thinks about things totally unrelated to paleontology or about
There's Mark Norell.
other things in paleontology. But immediately when you find something, you do start to concentrate.
Most people think of us as dinosaur hunters.
There's Michael Novacek.
And that's true, but it's only partly true. These rocks entomb a lot of different bones that represent an animal community that live.
Anywho, yeah, we've got that, and we've got... here we go. I know exactly how to find that spot right there. Look at the transcript. There we go.
But Mike Novacek leads the expedition, along with colleague Mark Norell.
There you go.
They could be taken for surfers, but they're from the American Museum of Natural History. Scientists piecing together an ancient jigsaw puzzle of evolution and extinction.
To me, it's so obviously important. I'm so emotionally bound up in this. I can't imagine
Michael
why
Novacek there.
a knowledge of our history, of where we come from, isn't important to a human experience.
Yeah.
Could you imagine what it would be like to live in the late 20th century and not know that extinction actually existed?
There's also
There's Mark
just
Norell.
a sense of discovery. I mean, every bone that we find tells us something about how the world was 80 million years ago, which is pretty neat.
So I like that clip so much that I made that one of my alerts. I think like a year or two ago. So we've had that for a while. That's Mark Norell. We're gonna miss him. Yeah. Here's a link to that documentary here. This is one of my very, very favorite paleontology documentaries. In fact, Denver and I used to watch this in the field when we would have... I remember, I think it was my second summer in the field. This would have been, what, 2012? Or maybe it was 2013? It was 2012. We would watch this when we would get rained out of the field. We couldn't go out and prospect. We couldn't go out and dig. It was too wet. Denver had this documentary on his hard drive. And so here we have a group of paleontologists and students sitting around watching a group of paleontologists do field work. Here we are in the field watching other paleontologists do field work. There's something poetic about that, I think. You know? Yeah.
80 million years ago, disaster came to a world ruled by dinosaurs.
The CGI on this is pretty hokey. It was the 90s, but...
It came in waves of sand and wind.
There's few documentaries as good as this. If you want to... I guess outside of watching these streams when I'm out in the field, if you want to get a picture, a well-edited, concise idea of what it's like to do field work as a paleontologist, this will give you a sense for that. Yeah. Downtime well spent. There you go, Tenno Stark. Yeah. Yeah.
For eons, the dinosaurs lay entombed in a place that would one day be called the Gobi Desert, in a country named Mongolia. Among the dead was one of the strangest dinosaurs that ever lived.
Anyway, this is Oviraptor again, like Mark Norell was talking about. And then here's the field
traveling to that distant desert to uncover the secrets of the Oviraptor's world. They don't exactly look like scientists. Often they're mistaken for each other. But Mike Novacek leads the expedition, along with colleague Mark Norell.
Anyway, we saw this clip already, but again, really good stuff. Maybe watch this in remembrance of Mark Norell. I'd recommend it. One of my favorite documentaries. And I saw this too. I was gonna wait maybe until tomorrow to talk about the new ornithomimosaur material there. I don't think it's been named, but it's in JVP. Dr. Tara was reading about this earlier. Exciting stuff. Unexpected. But yeah. And first ornithomimosaur remains from Germany. I hadn't heard about this yet. Cool. Nice. Very cool. Thanks, Dr. Tara. Excellent. Oh, and then, yeah, so Tenno Stark. I saw some headlines about this too, and here's the thing about fossils on other planets. I mean, I've been hearing about stuff like this since I was in middle school. And that was actually my first time ever visiting UCMP in Berkeley, before I started volunteering there in high school, in 5th grade, elementary school. My dad took me to Cal Day, the big open house at the University of California, Berkeley. And I got to meet some of the paleontologists there, and, you know, that was kind of a life-changing thing. But I attended a talk by the guy who I think was director of the museum at the time, Jerry Lips. There we go. There's Jerry there. So he was giving a talk about the potential to have fossils on other planets like Mars. And so he showed a bunch of different examples of purported Martian fossils. And none of those were particularly convincing. He was like, I don't buy any of these. I'm not discounting the possibility that life may have also originated on Mars, and that we might one day find fossils of it, but basically the idea behind the talk was, this sort of thing gets announced every few years. People really, really want to be able to find fossils on Mars, and each time that that's been announced, it's turned out to be nothing. Again and again and again and again. So I'm not going to get my hopes up about this time. It's a really tentative, like, I was reading the article about this earlier today, and it's a big maybe with huge asterisks on it. If it turns out to be a bit more plausible than previous claims, I'll definitely cover that at some point, but we're going to focus mostly on fossils that we know are actually fossils for today, if that makes sense. But I appreciate your enthusiasm, and yeah. It got me thinking about the future if when confirmed. I mean, if and when it's confirmed, we'll talk about it then. Yeah, but we've got so many other important pieces of fossil news to cover today, so we'll... Yeah. I don't know. I've had my hopes dashed so many times when it comes to this kind of thing. We're gonna sit back and wait for now, if that makes sense. Yeah. But, yeah. I, for one, am pretty skeptical of the idea that we'll ever find fossils on another planet. I'm not particularly optimistic about finding life outside of Earth, honestly. I don't want to get into a huge discussion about this right now, but if the ideas of some of my colleagues, which are as yet unpublished, but I've talked to some colleagues about this, if they're correct, the origin of life might require active tectonics on a planet in order to be able to create things like undersea vents under an ocean of liquid water. And Earth is the only planet that we know of that has or has ever had that, as far as I know. There's talk that maybe some of Jupiter's moons might have stuff like that. Europa leaps to mind, but yeah, I don't know. Anyway, yeah. And have you seen the Basilemes news? I've not, Dr. Tay. There's Basilemes news too? Huh. Yeah. And I appreciate you, Tato Stark. I was afraid you might be salty about this, so I appreciate your upbeat attitude here. I don't want to be a Debbie Downer about this kind of thing, so yeah. Anyway, we've got some really exciting fossil news to check out here. Well, yeah. And I'm on the same page as you, Petrodactylus, I think. Yeah. There's no room in science for being salty. I agree, Tenno Stark. It's a great attitude to have. Appreciate you. Yeah. Yeah, and there you go. Charlie's Dragon makes a really good point there, too. And, whoa. New Basilemes? Well. Basilemes is a big, probably terrestrial, almost tortoise-like turtle, while not being related to tortoises. Its name means king turtle. It's the biggest turtle in the Hell Creek Formation at the end of the Age of Dinosaurs, and it might go back to the middle of the Cretaceous period? That's nuts. Huh. Yeah, really cool critter, Basilemes. It's one of the few turtles that doesn't survive the end of the Cretaceous period. but I'll have to check that out. Really neat. Polar dispersal during the Middle Cretaceous hothouse conditions. Interesting. It's in historical biology, which unfortunately is a paywalled journal. If I'd known about this yesterday, I could have tried to snag the paper while I was in Berkeley, but I'll have a chance. Oh wait, what? No, there it is. Holy cow. Well, well, well.
Access granted.
Phenomenal. That's excellent. And Hamster Rain, thank you for the 2 months of support. I appreciate that. Good stuff. Hamster Rain, thank you for keeping me here online. Appreciate you. But yeah, are we turtly enough for the Turtle Club? Apparently so, says Dr. Terra. There you go. Yeah. Oh, and holy cow! 2 people I've done fieldwork with are authors on this paper. Giulio Panashi and Dave Varicchia, who is my undergrad advisor. Well, well, well. Very cool. Excellent. And it turns out all of these folks are from my alma mater, Montana State Department of Earth Sciences. Excellent. Excellent. Very, very cool. Small world indeed, yeah. Yeah, we interviewed Dave at the beginning of this year on the stream. It's back in January. Here we go. Oh, come on. How am I spelling his name wrong? Maybe it's not in the title? Search Troodon. There we go. Yeah, I guess it's got cut out of the title. But there's Dave right there. Yeah. Anyway, I'll give you a link to this VOD right here. But yeah, Dave is an expert on troodontid dinosaurs, especially Troodon, and on dinosaur taphonomy, dinosaur nesting, that kind of thing. Anyway, pretty cool stuff. Let's see. Oh, and I've done field work in this formation before, the Frontier Formation near Lima, Montana. Fragmentary turtle materials recovered from the Upper Cretaceous Frontier Formation. So we've got Basilemys material from the Frontier Formation. Nuts. And we've got a good date for it now, too. This is excellent. This is new stuff. Yeah. Very, very cool. Anyway, really neat. Excellent. I collected fossil footprints in the Frontier Formation, right on the kind of Montana-Idaho border. So southwest Montana. We were at it was like 9,000 feet elevation or something like that. It was right there in the Continental Divide. So, yeah, holy cow. Where's my... I might even have footage of this. Looking through my hard drive right now. Frontier Formation. This is taking forever to load. I apologize. This portable hard drive being really slow. Yeah, here we go. holy cow. Cosmo Quest, thank you for the raid. Welcome to Paleontologizing.
By dinosaur content.
It's wonderful to have you here, Cosmo Quest. How are things? I hope you're doing really well. It's good to see you here. Holy cow. Doing some science and technology today. Beautiful. And Danae Raven, thank you for the follow. It's good to have you here. Good stuff. Going to do some more digging this. Yeah, Casey. I'll be out there as soon as next Saturday. Doing some streaming there. Anyway, fieldwork like this that I did back in 2018. And it's not. Oh, come on. There we go. There's Julio right there, who's one of the authors on the paper. Here's me. Looking at some rocks there in the Frontier Formation. So this is above the tree line in Montana. This is like too high for trees to grow. This is at like 9,000 feet elevation. Air is very thin up there. It's super easy to get tired. Yeah. And there were bugs all over the place, too. Yeah, I was kind of surprised by that. So many insects for how little vegetation there is. Danae Raven says, been lurking for a bit, and this is my kind of stream. Love the vibe? That's wonderful to hear. I'm well pleased that you said that. Let me know if you've got any questions or anything. Welcome to Paleontologizing. Anyway, and Sully Two Cats. Thanks for the follow. Jim Kirkland there in that alert. He might be joining us out in the field in a couple weeks. Yeah, good stuff. Right chuffed. There you go, Claire, yeah. And, Tenno Stark. Not only am I attending TwitchCon this year, I'm on at least 2 different panels, and I might be doing some other special events too. We shall see. But yeah, on the TwitchCon schedule, if you do a name search for me, you get nothing. But if you search educational, you'll come up with this. Oh yeah, hang on. Oh yeah, I'll be on this panel, innovating in educational content on Twitch, with Science Streams, Ultrasaurus. Trash? Who's that? Huh. Must be a new addition. Cool. And Casey Snowart, of course, who is also here in the chat right now. And here we go. I'll be helping chair this panel as well. IRL Content Evolved Workshop. So this is going to be good. Yeah. So yes, I am indeed going to TwitchCon. Pretty excited about that. It's going to be good. Yeah. Anyway, how are you doing, Minnie? You've come back. She's telling us we got to get started with our fossil news here pretty soon. Yeah. And it's pronounced Tino, like the T. Interesting, Tina. Okay. I don't know if I'm familiar with... There's 3 E's? And hey, Science Streams, how are you doing, Valence? Welcome, welcome. Just talking about TwitchCon. I'm excited to see you there. It's going to be really good. Yeah. Mini Pie, you've come back. She's demanding Another rent payment, I think. I already paid you, Minnie. And look, you didn't even take all your payment there. You left all those crumbs. You better eat them up. You better eat them up. There you go. If you finish those, I'll get you some more treats. Oh, it's just one E. Okay, gotcha, Tino Stark. Yeah. Yeah. Cool. Anyway, we've got a ton of fossil news to get into today. But before we do that, let's, I'll forget. Don't do this now. Let's do Metazoa. This is our animal guessing game. Metazoa. It's a lot like Wordle, if any of you are familiar with that. But rather than trying to guess a mystery word of the day, we've got a mystery animal instead. And so we figure it out using a phylogeny, an evolutionary family tree. Let's start it.
Hold on to your butts.
We have to stay quiet. Yes, please do, Claire. I don't want any spoilers. So, the way that this works is there is a mystery animal. You type your guess here into this box, and the game will show you the most exclusive evolutionary clade that includes both your guess and the mystery animal. So give them the name of a placental mammal, chat. A kind of mammal that isn't a marsupial or a monotreme. This game is heavily tilted toward mammals. Oh, it's funny. When I was at Berkeley yesterday, I was talking with some colleagues about this, who also play Metazoa every day. And my friend Tanner there, who's now Dr. Tanner Frank, congrats to him. He says he always starts with a bird, because there's so many bird species. I think it's probably more heavily tilted toward mammals than it is toward birds, but yeah. Oh, my talk went really well, Balint. Holy cow. I was talking about that earlier on stream today. Very well received by my colleagues. And I actually have a special meeting on Monday, or Tuesday, next week, about maybe doing some collaborations with some folks at the museum. So I'm pretty excited about that. Yeah. What do you want? Do you want more treats? Is that what you want? Is that what you're after, Mini Pie? Is that what you're after? Yeah? Alright, we can make that happen. We can make that happen. Yeah, and brush time? I don't think so. I think she's a little bit too feisty right now to get brushed. So I guess we gotta pay her some more rent, huh? Huh. Yeah. 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 We'll start with 2. If you eat those, we'll get you some more. I don't want you leaving too many crumbs on my desk. She is all wound up, absolutely. Bitty boy. Yeah. Good you're crunching those. There you go. Eat up the crumbs. That's the thing, if I give her too many treats, she'll leave a bunch of crumbs there. But if I'm more sparing, then she'll clean them up. Huh. Huh. Yeah. You gonna eat those crumbs or no? There. That's it. That's it. Eat these. There you go. She's leaving a mess. That's okay. Oh, felines. All right. let's go with a cat for our guest. Let's do, I don't know, leopard. That's a placental mammal, and holy cow, we are nowhere close with that. Nowhere close. This could be tricky. Oh boy. Eumetazoa is this is like the very base of Animalia here. So here, I'll show you on our tree of life what we mean here. Let's go to Metazoa, which are the animals. Right here. Metazoa. We're at 1.4 million species, and I don't think we've narrowed it down very far. I don't think it's going to be in Placozoa. Where's Eumetazoa? Bilateria. So let's see here. Eumetazoa is a proposed basal animal subkingdom, a sister group of porifera sponges. So it's a non-sponge animal, it seems. Sponges are porifera. That's the clade name for these guys. So there's the sponges there. So with animals, we're at 1.4 million species. But we can knock 7,000 off of that list. Off of that figure. So it's got to be within here. So it's every animal that's not a sponge. But since we guessed leopard, and it gave us Eumetazoa, this tells us that it's as far as you can get from a leopard while not being a sponge within Animalia. Which actually gives us more information than you would... Jim says it's basal to sponges. Are you sure? Because Eumetazoa excludes sponges. Sister group of porifera. So yeah. By the way, Jim, it's great to see you. How are you? How is Germany? How was the conference? Everybody, Jim was in Germany for a conference. For the past week, which was excellent. I hope the conference was excellent, at least. Got to visit some track sites and stuff. And there's Jim's poster here. Brilliant. This is such a cool poster. That's super eye-catching. It's just... There's so much information encapsulated within this poster. Super, super cool. Pretty awesome. Jim, I hope you were able to preach the good word of Mesozoic Utah paleontology to your colleagues out there in Germany, and get them jazzed about the Jurassic Cretaceous boundary. And Germany was great, but caught the crud. Hopefully not COVID. Yeah, shoot. Fingers crossed, Jim. It's not COVID. Sorry you're not feeling well. I hope you're resting up and you're feeling better soon. Looking forward to seeing you out there at Lori's site sometime in the next few weeks, I hope, Jim. You get well soon, huh? Take care of yourself. Anywho, for Metazoa here, let's see. It's not a leopard, obviously, but it is a Eumetazoan. So Eumetazoa, also known as Epitheliozoa or Histozoa is a proposed basal group of animals as a sister group of porifera sponges. The basal eumetazoan clades are the Ctenophora and Parahoxozoa. So Ctenophora is Ctenophora. Who are those? Is that the like anemones and stuff? Or jellies? Ah, home jellies. Shall we try comb jelly, perhaps? I wonder if that's in the Metazoa database. Comb jelly. Nope. Gooseberry. Nope. I wish I had a better idea of like which ones are included in that database and which aren't. Jellyfish. That's an option, but that's the only thing. That and lion's mane jellyfish are the only options for jelly. Parahoxozoa. What group is that? Oh, okay. So this is like a super group. Bilateria, which are bilaterally symmetrical animals. Placozoa and Cnidaria. So this is a big clade. There's a lot in here. I'm guessing it. Let's try. Well, first I want to make sure that there's not like a common name that's slipping my mind with regard to comb jellies. I'm not seeing one, actually. It's the same article there. Let's try jellyfish.
Hold on to your butts.
There we go. And okay, we're close. It is a Cnidarian, which is good. That's a lot better than it could be. All right. So Cnidarians are critters with stinging cells. So that's things like jellies, anemones, some corals. So if it's not a jellyfish, but it is a Cnidarian. There we go. So this is jellyfish, hydroids, sea anemones, corals, and some of the smallest marine parasites, which are probably not going to be on the tree. So, is it going to be an anemone or a coral? I think there's like a 50-50 shot it could be either. But, there's only one kind of coral and one kind of anemone here. What do you think, chat? It feels like a coin flip. I think it's either going to be anemone or coral. What should I guess?
Their weapons would be powerless before the onslaught of the beast.
The what? I'm sorry. Again? What was that? I didn't catch it. One more time? I just keep talking over. What was that? All of a sudden, 4-2. Thank you so much for the 12 months of support. I really appreciate that. Thank you kindly. Yeah, so, and it says coral. Lordy says anemone. Jim says, what are you looking for? Well, here we go, Jim. Our mystery animal is some kind of Cnidarian, and it's not a jelly. So I'm guessing it's either going to be an anemone or a coral. And the only two species that are in this database, as far as I know, are just anemone generic and When you type in coral, the only thing they have is brain coral. So it's either going to be a brain coral or an anemone. I feel like it's a coin flip. Which one should I guess? We're trying to get this in the fewest number of guesses possible. Jim says hydrozoan. So it's a cnidarian. That's all it's telling us. And cnidaria includes... Let's see, well, where's hydrozoa? I don't think hydrozoans are in this. I don't think they have it. I don't think that's a possible guess here. Yeah, hydrozoa. Although freshwater polyp hydra is an option too. Huh. So I guess we have 3 guesses. Shoot. Oh! And sorry, I missed this message earlier. Thank you, Claire, for reposting it. Jim says, I think I pulled it off. A Jurassic mass extinction is now pretty accepted. Fantastic, Jim. Nice work. Mike Benton and my Chinese colleagues have invited me to join their JK extinction paper. Jim, is that the same paper that they... I hope it's okay that I say this. I assume they're not watching. The same paper that you were asked to review? I don't know if it was a blind review or not. But if that's the same paper that they asked you to review, and now they're asking you to be an author on it, that's really cool. Very, very cool. We will be fixing it up. That is fantastic, Jim. Holy cow. I can't wait to chat with you about this in person, if you're going to be out there in the field. Very, very cool. I know you were excited about that paper, but thought it needed some work. And now you get to help do that. That's kind of an ideal scenario, isn't it? That's awesome. Very, very cool. By the way, if anybody is wondering who I'm talking to right now, that is the official state paleontologist for the state of Utah, Jim Kirkland there, discoverer of Utahraptor and Gastonia. Yeah, Jim's a colleague, and I don't know, I consider Jim a friend. Good friend. Jim sometimes tunes in here, and it's always an honor to have him around. So you're in the presence of greatness, chat. That's Jim Kirkland there in the chat. Yeah. Good stuff. And I know you do, chat. Claire and everybody else. Jim is a perennial favorite on this channel. Big friend of paleontologizing. Appreciate you, Jim. Yeah. Yeah, here, let's see. We did a special stream, well, a number of special streams with Jim. But let's find the Utahraptor Mega Block stream. This was my biggest stream ever. We were on the front page for this. There's Jim right there.
This is so special. We call it the Utahraptor Mega Block.
Yeah.
For a short two-word explanation.
Ontogeny.
But yeah, it's we have interpreted this as being formed by quicksand.
Mm-hmm.
Basically, I was on the margin of a big lake sequence.
Mm-hmm. Yeah. Yeah.
Relative to this new little guy being closer to birds than anybody else we've got.
This was such a fun stream.
Yeah. You know,
Could
at
always
the
change.
moment.
Could always change. Yeah.
Yeah. No, the China Middle Jurassic stuff. Inchiornis is, but they're now saying that is a bird. You know, I mean, but they're still debating that. It wasn't Troodon a while back. But because of that thing, it's also got similarities to this.
Anyhow.
Change, no doubt about it. But James Napoli, I've told, is the guy that's going to be in charge of writing this stuff up.
Mm-hmm. Anyway, good stuff. Yeah. Hope you feel better soon, Jim. It's lousy to get sick after traveling like that, but I'm really glad the conference went well, and really glad people are on board with this, with what you've been able to figure out about how abrupt that faunal turnover is between the Jurassic and the Cretaceous in North America. It's exciting stuff. Yeah. Good stuff. Anywho, so we've got 3 possible answers for this. I'm going to go with anemone first. So let's see, anemone. We'll give that a shot.
Hold on to your butts.
And see if that gets us there. No. It wasn't that. It's not an anemone. It's not a jellyfish. It's not giving us any subclades underneath Cnidaria either. It's kind of one of the limitations to this game. Let's try coral, shall we? Brain coral. No! Darn it. It's gotta be... Jim, I should have gone with your suggestion. Freshwater polyp, hydra. This has got to be it, right? No, it's not. What? We are just burning through guesses. We've already done 5 out of 20. This is a tricky one. So it is within clade Hydroidolina, but it is not a freshwater polyp. What could this be? Here, let's look up Hydroidolina. Subclass of hydrozoans. What's even within this clade? Wait, Medusae? Hang on. The Medusae are the jellies. But we saw here... And, hang on, crack eggs. Thank you for the raid. Welcome to Paleontologizing.
Are about to get flattened by dinosaur content.
Thank you, crack eggs, for the raid. How was your stream? I hope it was really good. Hello to you, too. What'd you get up to today? Doing some IRL? Very nice. Welcome to Paleontologizing. Holy cow. Good to have you here. Shoot, my name is Danny Anduza. I'm a dinosaur paleontologist. We're about to go over some fossil news in a little bit. We're actually playing a quick game of Metazoa right now. It's like an animal phylogeny evolution guessing game. But, it's great to have you. From farming to paleontology. Well, welcome, crack eggs. It is, again, wonderful to have you here. Where did that... Oh, hang on a second. Should have pulled right up, but it's taken a second. There we go. This is what we're all about here on Paleontologizing.
My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs.
A limb bone from a new duck-billed dinosaur.
I invite you to tune in and experience the adventure of fossil science. There you go. That's what we're all about here. Welcome. Good to have you here, crack eggs. Thanks for joining us. Won't take you 9 guesses, Golganek. Yeah. There you go, Golganek. So our critter is within Hydroidolina, which apparently is the same clade as siphonophores and their relatives. Hydroidolina, okay. Which siphonophores. What's this over here? Jellyfish. Do say. Huh. It's not going to be lion's mane jellyfish, is it? Is that within this clade? Because if jellyfish is over here and then lion's mane jellyfish is within an entirely different subclade, I'm gonna be a little bit miffed. Because I almost feel like that's an error. Hang on. Here, let's zoom out. We can watch where this goes. If this is within clade Medusae for lion's mane. Hang on. It's like this is wigging out on us. What's going on here? Okay. Lion's mane jellyfish. I've never seen one zoom do this before, where there's a genus and species, and you click on it, and it doesn't take you to it. It's almost like it's programmed to say, yeah, we don't know where this taxon belongs, so we're just gonna take you to this clade with 5,000 species and just drop you off there. And Squiggle says, I mean, a manivore is a colony, not a true jelly, right? I don't know if they're cnidarians, though. So a manivore, manowar, Portuguese manowar. No, I'm not looking for a manowar fish. Oh boy, this is way trickier than I was hoping it was going to be today. Goodness. Very few times has Metazoa thrown us for this much of a loop. Let's do a genus and species search. So let's look it up on Wikipedia first and get the genus and species name. We'll get the binomial. Portuguese manowar. Species of marine cnidarian. There we go. Physalia physalis. We'll take that. We'll copy paste it into here. Pacific manowar, they're calling it here. Portugal. The famous Pacific country. There you go. Pacific manowar. Is that part of Medusae, or is it not? It is. It is interesting. Okay, let's try manowar here. You ready?
Hold on to your butts.
Maybe this will be it. There it is! Oh man, they did not make this easy. Oh boy. Okay. And it only took us, well, it took us 6 guesses, which is way more than I would have liked, but not the worst, you know? Let's share that on Blue Sky here. Today's was not easy. Weird Clade. But I got it. There you go. Nice. Yeah. Anyway, thanks for bearing with me during that chat. Let's take a look at what these critters are like before we get into our fossil news. Let's find a video on man-o-war, also called Portuguese man-o-war. Yeah. Let's take a look at this from SciShow. They always do good stuff.
This is a Portuguese man-o-war. It looks like it.
And I don't know if leatherbacks eat these. In fact, let's look that up real quick. I might have an opportunity to ask about this tomorrow, too, when I have my meeting down in Monterey. Not interested in AI mode. I'm gonna say, no. Let's see. Leatherback sea turtle. Let's find a good source of information. Not some AI slop here. Let's see. From Trinidad Express newspapers. There we go. Leatherback's crucial in man-o-war control. Well, well, well. Interesting.
A jellyfish, right? Heck, it even acts like a jellyfish. But it is not a jellyfish. In fact, it isn't even a single thing. The Portuguese man-o-war belongs to an order of extraordinarily weird animals called siphonophores. There are 175 species.
Oh, wait. Of course. I already knew that Dermachelys, the leatherback turtle, they eat siphonophores, and I completely forgot that man-o-war are part of siphonophoria.
Most of which live deep in the ocean. Many siphonophores look like gelatinous strands of rope, and some of them can reach lengths of 50 meters. That is
50 meters. That's like 25 meters times 2, to give you an idea of this is like half a football field. Are football fields longer or shorter in Europe, I wonder, and the rest of the world outside the US? Anyway, Nerduino, it's good to see you here. Yeah, that is like 5'10", Claire.
is longer than a blue whale. But their sizes and shapes aren't the only things that make them extraordinary. The weirdest thing about siphonophores is that scientists still haven't figured out if they're a collection of colonial organisms, like coral, or a single complex animal made up of specialized tissues, like we are. It's kind of...
So, we've seen this guy in a lot of videos before. He looks pretty young right here. I wonder if that's since been established, whether or not they are a single organism or whether they are colonial. This video is from 10 years ago. It does make me wonder. I wonder if there is a consensus that's formed around this since then. Man-o-war. Like all siphonophores, it is a colonial organism made up of many smaller units called zooids. So that it says that pretty confidently right there. I wonder if that is, if there's a true consensus there. Huh. Let's continue.
Kind of both of those things, and neither of them. Because usually a colony is defined as a group of organisms that work together but can function independently. But a single organism is composed of many interdependent units that can't survive.
And Jim says it's debated. I wonder if there's been a more recent consensus about this. Like whether within the past 10 years, if there's a general agreement about this kind of thing. I don't know.
On their own. Siphonophores have the scientific world all confused because their structures don't fit either of those definitions. I mean, they kind of resemble colonial organisms in that they're made up of little multicellular building blocks called zooids, and in colonial organisms like corals, each zooid can perform multiple tasks like feeding and reproducing. Since they can function just fine on their own, each zooid is considered a separate organism, and together they make up a colony. But the zooids found in siphonophores are different. From the outside, they look like they're functioning as part of a single organism that's hunting and capturing prey. But if you take a closer look, you'll see that they're so highly specialized that they almost work like separate organs and tissues. The biggest clue here is that they're arranged in a precise pattern, just like specialized cells are arranged to create tissues, like how brain cells form brains or muscle cells form muscles. Take nectophores, for example.
So I'll give you a link to this if you'd like to watch the rest of it, but there was also an Animal Fact Files video that I'm guessing might be a little bit more up to date. This is from a year ago. Let's check this out. Oh, I like how this is starting out, too. This is just my style. Surf rock like that?
Man-o-war is an increasingly common sight that adorns warm waters around the world, with their habit of making up about 70% of the surface of the world.
Huh.
But their biology is far from common.
Interesting.
Hi, I'm Danielle Dufault, and you're watching Animal Logic. The Man-o-war's mere
Jim says, angels on pinheads. I mean, to the... I guess it is kind of arguing over things that, like, does this argument really matter? I think that's what you're saying, Jim, and fair, yeah. Is it a single organism? Is it a colony? Yeah. Diagonal says, all zooids in the Man-o-war developed from the same single fertilized egg and are therefore genetically identical. They remain physiologically connected throughout life and essentially function as organs in a shared body. Hence, a Portuguese man-o-war constitutes a single organism from an ecological perspective, but is made up of many individuals from an embryological perspective. That's so cool. And it just goes to show that, like, when we as human beings, even as scientists, when we're trying to make sense of the natural world and kind of put things into categories, sometimes nature just doesn't cooperate, you know? Sometimes nature doesn't like to be fit into neat little boxes like this. There are certain species, certain groups, certain aspects of nature that kind of defy our very human impulse to classify and separate. And I think this is a beautiful example of that, you know? That's something to be celebrated. I think that's really cool, you know? Yeah. And Petrodactylus says, what a brain-breaking animal and how it works. Isn't that neat? Yeah. And there comes something that's both or none. Yeah, there you go. Danae Raven, exactly. Yeah.
existence puts into question our conceptions of what it even means to be an individual.
There you go.
Let's start with the basics. First of all, these little guys are absolutely beautiful. They look like delicate blown glass sculptures with satin frills attached to their underside that can be up to 30 meters long.
Jeez.
Their name comes from the type of sailing ships that Portuguese and Spanish explorers used in the 15th century. Columbus's first voyage to the New World was done in 3 men-o-war, also called caravels.
Yeah, the Nina and the Pina Colada, right? We'll go with that.
Voyage to the New World was done in 3 men-o-war, also called caravels. If you squint a little, you can kind of...
Oh, caravels. That's where you get ice cream cakes on the East Coast, right? Yeah. Yep.
To see it. Hey, the animals were probably most commonly seen by sailors and fishermen. What else would they compare them to? But maybe more than the shape, the resemblance is in its function.
I know, Arid. I'm making a joke.
This gas-filled bladder serves the double purpose of keeping the man-o-war on the surface and propping up the sail, which it uses to move around. Under the bladder, below the surface, the men-o-war have a series of tentacles and polyps for reproduction and to catch and digest prey. Because of this body plan and their general aura, men-o-war are often confused for jellies. But though they're distantly related, men-o-war are much weirder, starting from the fact that they're not technically an animal, but rather a whole colony.
Men-o-war are siphonophores. They're colonies of animals where thousands of clones take on different shapes and sizes to execute different tasks needed in the survival of the colony.
So, Mayor Spaces, maybe they should call this critter the Dairy Queen. There's a connection there? I mean, well, that's going to be the head animal in this colony is the Dairy Queen of the Carvel. And it hopes it doesn't get swallowed by Fudgy the whale. Yeah. What are we even talking about? Let's continue. Can they sting it? Absolutely, Lordy. Yeah, no, they could be super deadly, as I understand it.
So one individual can be a part of the sail, and another genetically identical individual.
Man-o-war is not men-o-war.
Digestive polyps.
I believe the plural is actually man's-o-war, and
It's pretty insane.
Siphonophores come in all shapes
obviously.
and sizes. The most commonly seen ones are chains of zooids, but other species very closely resemble jellies, tubes, and aliens. We'll come back to them in another episode.
Back on the weirdness of their colony. You might be thinking, what's the big deal with different parts of the man-o-war having the same DNA and looking different? After all, our brain cells, skin cells, liver cells, and every other part of our body have the same DNA, and the cells are different. Siphonophores are weird because they're not collections of cells like we are. They're groups of multicellular organisms.
In the case of the Portuguese man-o-war, these organisms, also called zooids, organize into 4 broad types of structure.
So I guess one way that you could think about it, and I'm not trying to be facetious right here, is that this is a multicellular organism whose cells are also multicellular. If each of the zooids is an individual animal, we can also think of them as like, each of them is acting like an individual cell, which is in itself comprised of multiple cells. Like, that's so weird and cool.
The ones above water that make the gas bladder and the sail form the pneumatophore. The long stinging tentacles used for capturing prey are the dactylozoids.
Yeah, so does anybody recognize that root word right there in dactylozoid? Dactyl. What does that term mean? Does anybody know? Dactyl. We already have a correct answer. Very good, Claire. It means finger. Yeah, Tenno Stark. Fingers. So, pterodactyl, which is a term that many people in the general public use to refer to pterosaurs. Yeah, that's a, well, dactyl means finger. So, pterodactyl, that term means wing, finger. We'll be talking about pterosaurs from Solnhofen later on in today's stream, because we've got a new publication on Solnhofen pterosaurs and their preservation. But, yeah, good stuff. So, dactylozoids, yeah, it means basically finger animals, Rushwing. Exactly.
The digestive appendages are called gastrozoids. And then the gonozoids are in charge of reproduction.
Let's start with the ones that are most likely to affect you personally. Their powerful, stinging tentacles.
So this answers your question there, Lordy. Can they sting? Oh, yeah.
Men-o-war can be blown into beaches in groups of up to 10,000 individuals. If you're in the water and you see an armada of man-o-war with their beautiful little sails floating in the water, run. Their stings are extremely painful and can be deadly for some people.
Yep.
Their tentacles are full of nematocysts, which are like bioneedles that inject poison as soon as they touch skin.
Yep. So the what are they? What was the term? Nematocysts?
Which are like Their tentacles are full of nematocysts.
I think nematocysts might be the same cells, like it might be the same term that we use for the stinging cells in sea jellies as well. Anywho, it's a similar concept, even if it's not the same exact term.
Which are like bioneedles that inject poison as soon as they touch skin. The venom is powerful enough to kill small animals like fish and mollusks, and to paralyze larger prey.
Yep.
The nematocysts remain active in dead man-o-war, even when they wash up ashore and dry up under the tropical sun.
The nematocysts cause immediate pain, which can last multiple hours or, in some cases, months. The stings make large welt lines that are a bit too graphic for this show. But just to get an idea, imagine a burn from a red-hot rebar. Yeah.
Yeah.
In some extreme cases, man-o-war stings cause respiratory symptoms that can lead to death.
Thankfully, the most effective treatment for man-o-war is just water at over 45 degrees Celsius or 115 degrees Fahrenheit. Vinegar and pee don't work, so no need to add urine to injury. Please.
Yeah. Ugh.
When they work, not as a self-defense tool, but as an assault weapon, they can easily kill fish. A large fleet of man-o-war can decimate fisheries.
Once the fish is fried, metaphorically, the meal is moved up the dactylozoids towards the gastrozoids. These are in charge of liquefying the prey and absorbing the nutrients through mouth-like openings.
Then, when their bellies are full and the mood is good and the water is warm, it's time to reproduce. Man-o-war produce both sperm and eggs. It's still unclear how they communicate with other man-o-war or what conditions lead them to release their sex cells, but they're believed to produce offspring sexually and asexually.
From there, the embryos will live as plankton until they grow large enough to build a pneumatophore and can float to the surface of the water.
So when we say plankton, that's not a term for like a specific kind of organism. So plankton is basically just like a class of creatures in the same way that, not even a class like as a taxonomic group, but just like a designation. It's like saying, oh, an SUV for a car, you know, where it's like, oh, it's larger. A true SUV is like body on frame construction rather than unibody construction. You know, so we search plankton, you know, you get a lot of this. Plankton from SpongeBob would not actually be plankton because he's not actually drifting with the current. As I understand it, planktonic organisms are generally small, pretty often microscopic creatures that drift along with the current. They might have a certain degree of self-propulsion, but for the most part, the current is carrying them along. So they're drifting creatures. I think if we were to do a, you know, ask Wikipedia to define it. Organisms that drift in water or air, interesting, but are unable to actively propel themselves against the current or wind. So these are animals, they're sometimes photosynthetic organisms like plants and other critters like that. Diatoms would be a kind of plankton, photosynthetic plankton. Yeah. And then you get zooplankton, which are animals. They tend to feed on phytoplankton. Sea jellies might be considered zooplankton, but like macrozooplankton, that kind of thing. Yeah, so in a way, man-o-war, even as adults, they might be considered like gelatinous zooplankton. But their offspring are definitely planktonic. They drift with the current. They're super small. You know, they're carried along like dust in the wind, essentially. That's what being a planktonic organism is all about.
Because of how efficient they
Oh, and by the way, I want to make the point that this is not just like specific organisms that evolved to be planktonic. The juveniles, the offspring of a lot of larger animals are also planktonic. So the way that a lot of fishes reproduce, they'll just produce hundreds or maybe thousands of offspring, and they're just like little tiny drifting things that eventually turn into little fry and then other critters like that. Or they continue to grow, but their offspring might be planktonic. This is true for things like corals. It's true for things like, I think, barnacles before they become sessile later in life. There's a lot of organisms like that whose young are planktonic. Crabs too. So like when crabs will spawn, there will be other animals that travel from around the world to go eat those planktonic offspring. So things like whale sharks will migrate halfway around the planet to be able to just feast on all of these little planktonic offspring of crabs and stuff like that. It's really cool how that works. Yeah. And there you go, Pfizer, yeah. And apparently comes from the Greek planktos, which means drifting. Interesting, Hamster Rain. That's really cool. Yeah. Here, that's probably here in this article. Yeah. Anyway, if you want to read more about plankton, this is a great place to start. There's a chance I may have made a mistake here or there, so if you really want to know about these organisms, about this way of being a critter, planktonic like this, read this article, and that'll set you straight. Yeah. Here we go.
They are at hunting and reproducing, and how adaptable they are to warm water temperatures.
1887.
Portuguese
Nice, Hamster Rain. Cool.
have taken over most of the world.
Their range is immense.
Oh boy.
And have been spotted as far north as Canada and Scotland, and all throughout the southern hemisphere, including New Zealand and Tasmania.
Shoot.
Wherever they go in massive groups and attract predators. They are important sources of food for charismatic species like loggerhead turtles, blanket
And leatherback turtles, the most charismatic of turtles in my opinion.
octopuses, blue dragons, and sunfish.
Yeah. Jay, what is that? It's a baby whale. Crimson says, wasn't the crash in plankton populations thought to be a major contributor to wiping out marine reptiles during the Cretaceous? Yeah, so like, what was it, like the Encenomanian? There was an anoxic event. Jim could tell you about this better than I could. And also Josh Lively, whom I'll be joining in the field as soon as next week. The end of next week. Next Saturday. We should be able to talk about that. I'm excited to be able to talk with Josh Lively all about marine reptiles, especially marine turtles. And I've been trying to learn more about these critters, actually, in order to have more productive conversations. I got an excellent book about this. Let me grab it and show you. Here we go. Darren Naish wrote this not too long ago. Kind of a newish book. Really nice primer, nice introduction to Mesozoic marine reptiles. It's called Ancient Sea Reptiles by Darren Naish. Really good stuff. Yeah. And this not only includes plesiosaurs, ichthyosaurs, mosasaurs. The more here is key because there's all kinds of obscure groups of marine reptiles too. Like the, what is this? Hupisuchians or whatever this guy is? What even is that? You know? Mystriosuchus? This looks like a Brian Eng illustration. I think it is. All kinds of weird critters like this featured in this book. Nothosaurs, Tanystrophiids, Placodonts. Yeah, what in the world? You know who this guy is. Yeah. Yeah, Topodentatus is a real Real weirdo, but we love it. And then Helveticosaurus? What in the world? Yeah. And then you get marine sphenodontians? Like Pleurosaurus right here. So this is a relative of Tuatara. These guys apparently became marine like on 2 or maybe 3 different occasions. So like multiple times, this group of organisms is going into the water, becoming marine. It's not one lineage, it's multiple lineages all independently doing this really weird stuff. But anyway, I've got to really become familiar with the mosasaurs so I can talk to Josh Lively when I'm out in the field, because that's his specialty. He loves mosasaurs, and he's named a few of them, as I understand it. But yeah. Crazy how many times reptiles get that, yeah, that anguilliform body plan there, Crimson. It's cool stuff. Yeah. So, yeah. Good stuff. Ancient Sea Reptiles, there in Naish. I actually recommended this book to Ralph Molnar the other day, ankylosaur researcher in Berkeley. This was last week. He mentioned this book, and I'm like, yeah, I just got that. You should pick it up. Excellent little introduction to marine reptiles. He's like, he feels like he's a little bit out of date with the... He's not necessarily privy to a lot of the recent work on these critters, and that's kind of this book's strong suit, is like, here's the current state of general knowledge on Mesozoic marine reptiles. Here's the things that we know. Here's the things that are still debated. Darren Naish does a really good job of saying, you know, here's the current thinking, and here's the stuff we're still not sure about. Does an excellent job of that. It's good stuff. And my talk went really well yesterday, Ceres Rainbows. We might end up doing a special stream to make up for our missed stream yesterday. We might do a special makeup stream on Saturday, and I might give that talk here on Twitch. I think that'd be a lot of fun, and I could talk about how well it was received too. So we'll see if I have time for that on Saturday. I've got a lot coming up, a lot going on. Leaving for the field next week, so we'll see if I have time. But that would be cool. I was very proud of how well received the talk was. My colleagues at Berkeley really enjoyed it, and their opinion means the world to me, so I'm very happy. Yeah. Claire says, if you can, we would love it. It would be cool, yeah. It would be an earlier stream than I normally do, because I've got stuff going on in the afternoon. I've got a party to go to at 3 or 4 p.m. on Saturday, so it'd have to be before then. Yeah. Anyway, let's continue this video on Man of War here.
These predators are adapted to eating jellyfish, which have similar nematocysts. They're immune to the pain, and on a good day can eat hundreds of men of war.
That party's also kind of work, but it'll be
other
cool.
Predators, the Portuguese man-o-war's chewy air bladder and stringy tentacles are simply not worth the pain of their stings.
A little fish, Nomius.
Hang on, is this... That to me looks like a green sea turtle. Like, what is it, Colonia Midas, I think? Do we have any turtle files in the chat? I think that's a green sea turtle, which would be on our turtle phylogeny right here, Colonia Midas. Here, can I use... Let's use our desk cam on this. Well. Whoop. And it's... Oh, it's upside down. Oh, well. It's worth a shot. But, yeah, here, let's continue.
A little fish, Nomius granovii, has learned this, and now lives mostly between the tentacles of Portuguese men-o-war.
This serves the dual purpose of protecting them from predators and finding food. The fish can take nibbles of the man-o-war's catch, and in some cases, will eat some of the smaller and less painful tentacles.
Because of...
And Dr. Irrefutable, thank you for that Ko-Fi donation. Appreciate that. What is this? 50 for fast field fuel fill-up. Really appreciate that, Dr. Irrefutable, rather. Thank you so much, Dr. Irrefutable, for that donation there on Ko-Fi. That'll get me like halfway to Utah with how fuel efficient the Prius is. I appreciate that very much. Thank you, thank you. It's good stuff. Fantastic. And I'm sorry, there's also Dr. Terraminator here in the chat, and you two have the same color to your username here on OBS. So yeah, but I appreciate you, Dr. Irrefutable. Thank you, thank you. There's a reason you've got that VIP badge there. Appreciate you. Good stuff. That does help out a lot. Okay, let's finish out this video, and then we'll get into fossil news, okay?
They are known simply as man-of-war fish. I'm not sure why they pronounce the F in this case.
I'll be right back. I gotta run to the bathroom.
The relationship between the clownfish and
be right
the
back.
sea anemone. But while the clownfish has a mucus that protects it from the stinging tentacles of the anemone, the man-of-war fish relies on agility to avoid painful stings.
One wrong move, and it can get stunned and left on the path of the countless predators of the Portuguese man-o-war, and those who avoid siphonophores, but wouldn't say no to fish for dinner.
But man-o-war are not afraid of predators, mostly because they don't even have a brain. All of those potential predators don't stop Portuguese man-o-war from visiting warm water beaches, where they unfortunately end up drifting into a lot of oblivious beachgoers. It's impossible to know how many people get stunned every year, but man-o-war and jellyfish combine for over 150 million stings a year.
In some cases, the conditions become perfect for mass stinging events, like in 2018, when over 200 people were simultaneously stung by a massive legion of Portuguese man-o-war.
In the summer of 2024, warnings have been issued in Florida, the Gulf Coast, the Cayman Islands, Bermuda, the American East Coast, Nova Scotia, and the UK. That's tens of thousands of kilometers of beaches where you have to be wary of these beautiful, spicy sea creatures.
And as average ocean temperatures rise, Portuguese man-o-war are expected to increase their range to most of the temperate seas of the planet, where most of the world's coastal populations live.
Thankfully, since they don't really have much of a choice of where they go,
Yep.
their movements can be determined using mathematical models.
Just
Oh.
by knowing the wind speed and the man-o-war drag coefficient, scientists predicted their arrival in the Basque Coast. Further research has treated them as sailboats and has used computer aerodynamic and hydrodynamic forces to predict their movements.
One day, not too far off, every time we go to the beach, we'll have to check both the weather and the man-o-war reports. And as the ocean heats up, the man-o-war will have an even greater area of the world to colonize.
Yep. Which is cool. It's a cool organism, but also you don't want to go to the beach and just get horrifically painful stings from an invertebrate that doesn't even want to sting you. You know? Which is one of the reasons why we have to protect these critters. Dermachelys coriacea, the leatherback turtle. I'll give you a link. Oh, first I'll give you a link to this video from Animalogic. Yeah. Brilliant stuff from Danielle Dufault there. And then here is a link to this article here. There is a link between deadly man-o-war and leatherback turtles. According to the U.S. Fish and Wildlife Service, leatherbacks feed primarily on sea jellies, as well as the man-o-war. His long tentacles deliver a painful, venomous sting, powerful enough to kill fish, even humans. So the fewer leatherbacks there are, the more man-o-war there will be. The Express asked Kyle Mitchell, chairman of Nature Seekers, a leatherback conservation non-governmental organization. You might be hearing more about Nature Seekers on this channel in the future. We'll see. This publication asked Kyle Mitchell of Nature Seekers if the sudden influx of man-o-war on East Coast beaches was linked to the large, gentle creatures. He said, yes. Leatherbacks do feed on man-o-war, and there is a declining leatherback population in the area. However, there's no available data at present linking the present influx of man-o-war with declining leatherback population for him to work with, he said. And spoken like a true scientist, yeah. And Kennedy, yep, ocean sunfish eat them as well. Like the video said, yeah. The influx of Portuguese man-o-war on Trinidad and Tobago beaches, especially Manzanilla, has caused alarm among beachgoers because of their painful sting, which can cause paralysis and dizziness. Commenting on the decline of leatherbacks in Matura, Mitchell said, if you come to Matura Beach during the peak of the season, March to August, you can easily see 15 to 20 turtles, and you might think that's a lot. But in previous years, you could see between 25 and more turtles nesting. We did a report in 2018 that shows there is a 5% decline in leatherbacks coming to nest on Matura Beach every year. So every year, 5% fewer of these turtles. If the decline continues, and if the man-o-war influx so happens to be connected to it, it means we should see a continuous influx of man-o-war washing up. Yeah. Jellyfish and man-o-war feed on baby fish and fish eggs, so this can also mean a decline in fish stock, too. Anyway, in nature, so many different things are connected, and we're going to be talking a lot more about leatherbacks in the future, but, you know, here that is again. Tomorrow, one of the reasons why I'm going to be, well, the reason why I'm going to be a little bit late to stream tomorrow, there we go, starting late, is I've actually got a meeting down in Monterey, California, about leatherback turtles. I've been looking forward to this for a long time, and yeah, I might be able to give you details during tomorrow's stream. Yeah. Anywho. Yeah. With that having been said, the drive should be nice. I hope so too, Claire. I hope there's not too much traffic. I wish I could take public transit there, but there just isn't anything. So driving it is. With that having been said, and yeah, there you go, Otter. Good to see you, by the way. I'm excited about this. Campanias. So I'm not going to be having lunch there, Jerry Andrews, I don't think, but we'll see. We'll see. We've got a bunch of fossil news to cover, and we've got just about 2 hours to do it. So let's jump into fossil news right now. All right, first off here, let's do coelacanths. Always fun to talk about. And we've got multiple new species of fossil coelacanths today. Super, super exciting stuff. Several new species of coelacanths that lived at the end of the Triassic period, some 200 million years ago, have been identified from museum specimens unearthed over 150 years ago in the UK. So we've got new British coelacanths in a Swiss museum. Holy cow, let's get into this. So, first off, maybe I'll try and explain why these critters are so cool. By the way, we've got a coelacanth here, and here, and here in our background today. Trying to keep things nice and topical. Let's see here. What would be a good intro? Here. We've watched this video before. We'll watch it again. It is just a joy. This is the story of the coelacanth. From HHMI. If any of you haven't seen this before, I think you're going to love this, especially the animation style. It's very charming.
You have this fish it's like a sort of living time machine.
It was like looking at a dinosaur. This creature that has been around for 400 million years.
Since long before the dinosaurs. Yeah.
It was December the 22nd, 1938.
And this is a date that we celebrate every year here on this channel. I call it Fishmas. Yeah, anyhow. We'll have a special stream for it again this year, I think.
On this hot December day in East London, South Africa, a trawler came into town and deposited its load of fish, and the trawler captain had a habit of keeping any odd-looking, interesting specimens and giving them to the curator of the local museum, Marjorie Courtney Latimer.
She loved nature so much, and she wanted to make the museum's collections the best they possibly could be. And so she went down to the harbour side. She describes picking through this big pile of slimy fish and eels, and then suddenly she saw poking up this sort of strange blue fin.
It's a very distinctive kind of fish with strange fleshy limb-like fins. This thing was like nothing she had ever seen.
Incredibly strange.
Said to the chairman of the museum, I think this is something really special. He went, oh no, little Latimer, it's just a rock cod. But she knew in her gut that it was something different.
And we all owe her a tremendous debt of gratitude for this, that she realized this was something incredibly special. She didn't quite know what it was, but she knew this was different. This was important.
She thought, well, I've got to find a way to preserve it. So she set off on Christmas Eve in East London.
And again, hence Fishmas here. This is a t-shirt that I produced last year, which I'm honestly really proud of. It's like a Christmas sweater, but Merry Fishmas. Yeah. I designed and printed this myself. Screen printed it. Yeah, especially for Fishmas.
She tried to get the local cold storage company to take care of it.
They said, oh, no way, go away.
She tried to get a local mortuary to embalm it.
They said, oh, we can't have any stinking fish here. She said, why? All the other people in here are dead anyway.
Good
So
point.
eventually it was given to a taxidermist.
And she thought, well, I've got to find someone to identify this fish. And she immediately thought of Professor J.L.B. Smith.
Yeah. And J.L.B. Smith, he's the guy who wrote this book that we were talking about at the beginning of this stream, Old Four Legs. Again, a classic piece of popular science writing. He was actually a chemist by trade. That was his day job, but he didn't really enjoy chemistry. I think he actually kind of hated it, even though he was good at it. Ichthyology was his passion. So he was, people call him an amateur ichthyologist, just because I guess it didn't say ichthyologist on his paychecks or whatever, but he published many papers and books on fishes, and he was one of the world authorities on fishes of South Africa.
Who was the only ichthyologist in South Africa.
So she drew a rough little drawing and sent a letter. As soon as he saw the fish, he walked round and round it slowly.
He practically fainted.
He said it was like bombs going off in my head, and I was seeing the shape of a fish known only from fossils.
It's such a characteristic shape. It's like the outline of a Viking ship.
This was the coelacanth, a fish that was thought to have become extinct 65 million years ago. It was like a dinosaur had just come into your living room.
You know, 400 million years ago, these were just a bunch of fishes, very much like other kinds of fish that were around at the time. But now they are these absolute anomalies. There's nothing else like it on the planet.
They had, in fact, made the discovery of the century.
It was given the name Latimeria chalumnae in honor of Marjorie Courtney Latimer.
Without her, the specimen wouldn't have been preserved.
The key excitement was the fact that this was such an obvious living fossil.
Charles Darwin came up with the term. It's sort of dumb in a way, because if it's alive, it can't be a fossil. Well, what it means is there's an early fossil record, then a total gap, and then there happens to be a living one. It doesn't mean that hundreds and hundreds of its relatives haven't become extinct.
And we'll be talking about some of those relatives just described now in this new paper.
One of the things that I love about the coelacanth is that it's seen history past.
When the coelacanths first appeared as one lineage of lobe-finned fishes, among other similar-looking forms, well, what can you say about the world? They shared the waters with strange, armored, jawless fish with sucker-like mouths.
Yeah.
One lineage of their close relatives started nosing around in the shallows, and then I suppose from the coelacanth's perspective just sort of disappeared out of view as they emerged.
These are our ancestors, creatures like Tiktaalik. You know, these what we call fishopods. So it's like an ancestor. Well, it is an ancestor of the tetrapods, the animals with bones that live on land.
Up onto the land.
I like to sort of think of the coelacanth as saying, "Bye and good luck."
We get into the period of the coal swamps, producing so much oxygen that it becomes possible for dragonflies the size of falcons and millipedes longer than a man. The world is suddenly struck by a gigantic mass extinction. Something like 90% of all species disappear.
It's at the end of the Permian period.
Sort of keep going. They're perhaps taking a bit of a knock, but there are quite a lot of them. They swim around, do their coelacanth thing.
Yep.
Another huge mass extinction. Then mammals diversify on the land, primates emerge, one primate lineage starts standing up on its hind limbs, starts speaking, and here we are. And meanwhile, coelacanths, well, they haven't really changed.
They have changed, but they're still recognizable as coelacanths, I guess. You know? They still have this characteristic shape. They're still what you would point to and go, that's a coelacanth. The same way that they've got many of these same characteristics that they had 400 million years ago. Like the beginning of their fossil record, you know?
That is a truly astonishing thing. For me personally, it is just that the world should have such things in it. That it should be possible to see this kind of improbable, ghostly messenger from the very deep past.
And I just hope that the coelacanth manages to outlive us all and keep going and witnessing what is to come.
I think it's beautiful. So there are 2 known species of coelacanths. They live on steep underwater slopes off the coast of East Africa and Indonesia. Population size isn't known, but they are considered threatened. Yep. Incredible animals. They're so cool. There. Here is a video from National Geographic of some divers encountering a coelacanth. And this is a big fish. They can be like 2 meters long, like over 6 feet. This is the West Indian Ocean coelacanth, Latimeria cholumni. They are impressive creatures. And Vexy, yeah, coelacanths were alive long before the dinosaurs. So here, to give you a sense for what we're talking about, go to our time scale here. So we're here at the, well, so far, the end of the Cenozoic era. It's continuing, but yeah, we're up in those black pixels up there at the top of the Cenozoic. 0 million years ago. The dinosaurs, all of them except for a few species of bird, go extinct at the end of the Cretaceous period, 66 million years ago. This is when it was assumed that coelacanths went extinct until Marjorie Courtney Latimer found a live one. Like, incredible. Coelacanths existed all throughout the Cretaceous, and the Jurassic, and the Triassic. Dinosaurs only evolved about 240 million years ago, probably at the end of the middle Triassic, thereabouts. But coelacanths first evolved back in the Devonian, probably the early Devonian period. So about 400 million years ago, give or take a few. So coelacanths are older than the first dinosaurs, and they also survived, barely, but they survived the end of the Cretaceous too. And they exist until the present. So they can be encountered by people. Pretty astonishing, right? Yeah. Like, what an incredible creature. They're beautiful, too. They're not just interesting on a conceptual level. They're not just special because of how ancient they are, or how different they are from all other modern fishes. They're also just a beautiful animal in their own right. The kind of gracefulness that they exhibit. The way that they can kind of hover in the water and just move these lobe fins like this. They can pause, they can turn over on their side, they can do a headstand, they can swim forwards or backwards. Using these fleshy lobe fins like this. Just incredible. So today there's 2 species around that we know of. But there were so many more during the Mesozoic, during the age of dinosaurs. These were common animals, like, they were diverse. And they occupied not just marine ecosystems, but they were common in freshwater environments, too. They were some of the top predators in lakes and rivers, and estuaries and deltas, and yeah, they were all over the place. Super cool. And Vexy says, any other fish creatures that survived the Cretaceous? Well, I mean, all fishes today are descendants of fishes that lived during the Cretaceous, too. Yeah. But many of those groups had, like, a big diversification event after the end of the Cretaceous. Coelacanths are so special because they were well known as fossils prior to the 1930s. Everybody assumed they were extinct. Here's this weird fossil fish that disappears from the fossil record at the end of the Cretaceous. And then suddenly, in 1938, Marjorie Courtney Latimer, she finds a recently dead one. It had been alive like that morning. And Reagan Nation, thank you for the Ko-Fi donation there. Wow, what is this? Holy cow! Thank you, Reagan Nation. My goodness. Thank you for your generosity there. For the fish creatures, Reagan Nation says. I appreciate appreciate that very, very much. Thank you kindly. That should pay for all of my fuel going to Utah and probably coming back too. I appreciate that so much, Reaganation. Really appreciate that. Thank you so much. Good stuff. Yeah. Excellent. And Gasman, exactly, Tenno Stark, yeah. Yeah, thank you, Reaganation. I really appreciate it. Zul says, how can some ancient mammals survive, as well as some birds, but not dinosaurs? Well, so that's kind of the big question, isn't it? Here's a figure that I like to show. This hasn't been published yet, but this is a figure from a paper that's hopefully coming out pretty soon. So here's different creatures. These are terrestrial or freshwater animals. This might be worldwide, or this might just be from North America, but these are the extinction rates for different groups of creatures. It's 100% of the non-bird dinosaurs died out when that asteroid hit 66 million years ago. They're all gone. Only the birds survived, and only a handful of bird species. Birds almost got completely wiped out, too. About 94% of bird species, we think, died out at the end of the Cretaceous. About 90% of mammal species. About 92% of lizards and snakes. But then in freshwater ecosystems, creatures fared a bit better. So about 40% of the freshwater fishes species died out, but only about 20% of turtles and crocs, 20% of salamanders. So there was definitely, it paid to be a freshwater organism. That's probably because a lot of these creatures are kind of feeding on detritus and just crud that kind of falls into the water. And so even during an apocalypse, they're still finding stuff to eat, when the creatures on land are mostly all dying. Creatures in the ocean actually did a lot worse, it seems, because that food chain is primarily based on phytoplankton, like we were talking about. So when the asteroid hit and it blocked, threw up all of this dust and soot, blocked out the sun, that caused the marine food web, the ocean food chain, to just collapse. So with the plankton that produce their own food from sunlight, if there's no sunlight, they die. The creatures that eat them, the zooplankton, die. The fishes and other invertebrates and critters like that feed on zooplankton, they died. And then the marine reptiles that feed on those fishes and stuff, they died too. So nearly everybody died in the oceans as well. Freshwater ecosystems did a bit better. Coelacanths probably took a really bad hit from that asteroid impact. They probably almost went completely extinct, because to my knowledge, there's still 0 Cenozoic coelacanth fossils. So for the entire Cenozoic, the entire age of mammals here, we have, as far as I know, 0 coelacanth fossils. So they became rare enough that they're just not preserved in the fossil record all throughout the Cenozoic. That's why it was so surprising when Marjorie Courtney Latimer found that coelacanth in 1938. So yeah, does that make sense? Yeah. Anyhow, so with that, let's get back to our new paper here. We've got multiple new species of coelacanth from the Triassic period. So the Triassic is the beginning of the age of dinosaurs here. Triassic, Jurassic, Cretaceous. So we've got coelacanths from the Triassic period, so over 200 million years ago. Coelacanths are evolutionarily unique lobe-finned fishes that first appeared in the fossil record in the early Devonian, around 419 million years ago, give or take. Over 175 fossil coelacanth species are known throughout the Paleozoic and Mesozoic eras. During the Mesozoic, they diversified significantly, with some species developing unusual body shapes. However, at the end of the Cretaceous, around 66 million years ago, they mysteriously disappeared from the fossil record, just like I was telling you. It was presumed that coelacanths have been swept up as a casualty of the end Cretaceous mass extinction, but in 1938, the first specimen of the living species, Latimeria chelumnae, was caught fortuitously in South Africa. Our team realized that many fossils previously assigned to the small marine reptile Pachystropheus actually came from coelacanth fishes, said University of Bristol's Professor Mike Benton. Well, shoot, Mike Benton was mentioned in the chat earlier. He was there at the same conference that Jim was. Small world. Really cool. Yeah. Many of the Pachystropheus and coelacanth fossils have uncanny similarities. But importantly, we then went off to look at collections around the country, and we found the same mistake had been made many times. So this animal, Pachystropheus, doesn't look anything like a coelacanth, but if you find isolated bones from it, if you find isolated bones of coelacanths, and these animals are pretty common, you might go, oh yeah, they're probably Pachystropheus bones. Yeah. Interesting. Very interesting. There we go. It is remarkable that some of these specimens had sat in museum storage facilities, or even on public display since the 1800s, and have seemingly been disregarded or identified as bones of lizards, mammals, and everything in between. It's the University of Bristol paleontologist Jacob Quinn, lead author of the study. From just 4 previous reports of coelacanths from the British Triassic, we now have over 50. Holy cow. That is impressive. The paleontologists made X-ray scans of many specimens to confirm the identifications. The specimens mostly belong to an extinct group of coelacanths, the Mawsoniidae, but closely related to the living fish. Very cool. And thank you, SillyVal1 for the follow. Welcome to Paleontologizing. It's good to have you here. Although the material we identify occurs as isolated specimens, we can see that they come from individuals of varying ages, sizes, and species, some of them up to 1 meter long, and suggest a complex community at the time, said Universidad de la República de Uruguay paleontologist Pablo Torino, co-author of the study. The coelacanth fossils all come from the area of Bristol and the Mendip Hills, which in the Triassic was an archipelago of small islands in a shallow tropical sea, said co-author Dr. David Whiteside, a paleontologist at the University of Bristol. So, this is around this time when, here we go. Maybe we go to 220 million years ago. There we go. Yeah. So here's the UK right here, right? So this would have been a series of islands and a shallow kind of, maybe even tropical sea right here. Kind of beautiful habitat for critters like coelacanths. Yeah. And it is working for me. Yeah, I had to just, I don't know what the issue was, Claire, but it's working again. Yeah. Anywho, good stuff. An archipelago of small islands in a shallow tropical sea. So you might think about modern day England and go, this doesn't look like good habitat for a coelacanth, right? Not the sort of place you'd expect to find non-tetrapod lobe-finned fish, right? But it didn't used to look like that. It used to look like this. Or, I suppose... like, much like this. There's like ichthyosaurs swimming around during the Triassic. This is a Jurassic ichthyosaur, but you get the idea. Yeah. So, like modern-day coelacanths, these large fishes were likely opportunistic predators, lurking around the seafloor and eating anything they encountered, probably including these small pachystropheous marine reptiles, which is ironic given their fossils have been confused with those of coelacanths for decades. Very, very cool stuff. And that's kind of what you see right here, is there's one munching on a pachystrophiid right there. People forget that, you know, these coelacanths, we think of them today as being kind of vulnerable creatures or these great survivors of the deep. They're threatened with extinction right now, that like their numbers might be declining due to overfishing and perhaps pollution and things like that. I'm not totally sure, but these are big critters, and they're eating whatever they can fit in their mouths, basically. Especially during the Mesozoic like this. Some of the biggest coelacanths during the Cretaceous are critters like Mawsonia. These guys are big. Truly impressive animals. And our new species of coelacanths seem to be members of the same family, according to the paper. They're also Mawsoniids like this. Really cool. Let's take a look at that paper. This is in the Journal of Vertebrate Paleontology, which is normally paywalled. However, ooh, not today. Not today.
Access granted.
There we go. I'll give you a link right here if you'd like to follow along at home. There you go. Coelacanthiform fishes of the British Rhaetian. So the Rhaetian is a stage, or I guess an age, within the Triassic period. So Triassic, there's the Rhaetian right there. So from the late Triassic. Pretty neat. And the alive coelacanths are big. They are, Dr. Terry, yeah. Yeah. Especially the West Indian Ocean coelacanth. It's a big critter. So we'll take a quick look at this paper here. We're not going to read through the whole thing. But, yeah, this is neat. So this is not the result of a new discovery in the field. This is a new discovery in museums. Sometimes when we're talking about museum collections, our job as paleontologists in the field is to collect specimens and collect good data, bring that back to a museum, put it there into that museum, and then keep it safe for years, decades, centuries. And these fossils had been sitting there in museum drawers for like 150 years, just waiting for the right people to come along and re-identify them, because they'd been previously misidentified. I mean, 150 years ago, we didn't know quite as much about these ancient faunas, about the creatures that inhabited them, these environments. So there's new discoveries to be made, not just out in the field, but in museum drawers as well. It's kind of a cliche in paleontology that, like, oh, not every discovery comes from the field. And honestly, I kind of take issue with that because, yes, every new discovery does come from the field originally. How do you think those fossils got in the museum in the first place? Field work is crucially important. It is the foundation upon which our science is built. But museums are really important too, obviously. That's why we're collecting these things, is to put them into museums. So this does highlight the importance of preserving these specimens, of maintaining these museums, continuing to fund them, making sure that we have a safe place to put these fossils so that researchers hundreds of years into the future will be able to study these specimens and reinterpret them if necessary, like happened here. This is cool stuff. Yeah. And Deathsaurus says that's why there's still plenty of work for folks who don't like or can't do field work. Absolutely, yeah. True. Yeah. Anywho, very cool. So we highlight taxonomic misidentifications to show that coelacanth specimens from the British Rhaetian have been confused as far back as the late 1800s. Numerous morphotypes of many bones in the sample hint at a complex community structure with individuals of varying size, age, and likely several species supported within the ecosystem. Very cool stuff. Did they actually name any new coelacanths here? Systematic paleontology. Here we go. I don't know if they name any new critters here. So we've got descriptions of different bones from different parts of the body: skull roof, neurocranium, palate, cheekbone and opercula, hyoid arch and branchial apparatus, postcranial skeleton. Good stuff. Looks like they even have 3D models of some of these. Very cool. Nice. Cool. So I don't know if they've actually erected any new taxa, any new genera or species, but it's still, this is exciting stuff. And there we go. There's a piece of paleo art there by Daniel Phillips. Interpretive reconstruction of a large mossoniid coelacanth alongside several juvenile individuals of the Rhaetian thalatosaur, Pachystropheus. The thalatosaurs don't get nearly enough love. It's cool to see. Pretty neat. And kudos to the authors and the journal for making this open access so anybody can read it with no paywall. This is really neat. So, very cool stuff. Very cool. Always neat to see new coelacanth work. Happy about this. And those are not plesiosaurs, Squiggles. These are thalatosaurs, which are a different group of marine reptiles. Here. I was first introduced to thalatosaurs through this book over here. Dinosaurs and Other Mesozoic Reptiles of California. Thalatosaurs are, I think, a really underappreciated group of Triassic marine reptiles. They're neat. They, like I said, they don't get enough love. But they're not plesiosaurs. They're a totally different group. There is a skeletal reconstruction of a thalatosaur right there. And there is a nice fleshed out reconstruction of a thalatosaur in life. Think of it almost like a reptilian sea lion or something like that. These guys may have been, we know that they were marine, they lived in the ocean, but they may have come up onto land in order to chill out, sun themselves, rest, that kind of thing. I'm trying to find that illustration here, too. Oh, it's in here. Ha, there we go. So here they are on some rocky outcrops, kind of resting up there outside of the water. So these are animals that would have, they would have pursued their prey in the ocean, swum around a whole lot, but given that they've still got limbs that are capable of terrestrial locomotion, maybe they're like seals or sea lions, where they're hauling themselves out and kind of resting up on the beach, or on rocky outcrops like this, maybe on top of reefs, whatever. Yeah. Very cool. There's an ichthyosaur swimming around doing its thing down there, too. Notice the flippers. These guys cannot come out of the water without dying. These guys can. Thalatosaurs. Let's see. There we go. Thalatosauria. If you want to read more about these animals, here's a link. Oh, and there you go. Claire Burr already posted it. Well. Nicely done, Claire. But there's a lovely illustration here. Beautiful. Cool stuff. So anyway, that's these little baby ones are being gobbled up by this big Mawsonian coelacanth there. Neat stuff. Yeah. And I like the overbite. Yeah. I've held some of the skulls of these critters, and that schnoz is pretty interesting, to say the least. They're cool. They're very cool. Some of them have got a big old notch like that. Some of them don't. Some of them got a nose that almost looks like needle nose pliers. They're cool. Thalatosaurs. Underappreciated marine reptile. For certain. In fact, let's look at what Darren says about them in that other book that I was showing you. There we go. Thalatosaurs. So this is one of these like weirdo Triassic marine reptile groups. We had marine phytosaurs too? I didn't even realize that. That's nuts. Marine reptiles are so cool. They're just bonkers animals. Mesosaurs. Triassic Sauropterid. Let's just look up the... Yeah, it's got to be chapter 4. There we go. Where's our thalatosaurs? Nothosaurs? Claudiosaurus, Placodonts, Cymodontoids, which are the turtle-like Placodonts. This is not a turtle, but a part of another group called Placodontia. Pachypleurosaurs, Nothosaurs, Pistosaurs, which are kind of like plesiosaurs, but they're not plesiosaurs. Phytosaurs at sea, Pupasuchians, Thalatosaurs. Here we go. Yeah, this group right here. Another obscure Triassic group are the Thalatosaurs, known formally as Thalatosauria or Thalatosauriformes. They became known in 1904 when American paleontologist John Merriam, this is the same guy who worked at Berkeley. He was one of the first paleontologists at the Museum of Paleontology at Berkeley. John C. Merriam, and I've talked before about how this portrait of him was up on the wall when I was at Berkeley, when I was a high school volunteer there, when I would be alone in the back room of the museum there for hours and hours on end. His portrait would be there just staring at me the whole time. And sometimes it kind of seemed like his eyes would follow you as you'd walk around the room. No matter where you stand, Merriam would just be staring at you. So I used to say hi to him every day. I'd show up for my volunteer work. I'd set up my little station in the back room, the microscope and stuff, and be like, "Hi, Dr. Merriam. Good to see you this morning." So yeah, John C. Merriam described a new marine reptile from the late Triassic of California. That's where these critters were first found. Yeah. He originally thought they were ichthyosaurs. But more complete remains discovered by a patron of the research, Annie Alexander, who founded the museum. She revealed the unusual nature of this group. He named it Thalattosaurus. It's about 2 meters long, long-tailed, and had vertebrae indicating lateral flexibility and an anguilliform swimming style. So it swam kind of like an eel. Yeah. Cool critters, Thalattosaurs. They're pretty neat. Yeah. And Copernicus cat, the ichthyosaur's Nevada state dinosaur. Ichthyosaurs are not dinosaurs, Copernicus cat. You're thinking state fossil. I don't think Nevada has a state dinosaur yet. There's only one dinosaur that's ever been named from Nevada. It's Nevada Dromius. It was published just a few years ago. But yeah. That reminds me, I actually need to send an email out to a colleague, because I'd like to get involved with ichthyosaur fieldwork in Nevada next year. We'll see, I need to do that. Yeah. Anywho. Yeah. Anywho, really cool, cool new paper on coelacanths from England. Neat stuff. Yeah. And Dr. Morbius, I did a live stream from Berlin Ichthyosaur State Park a couple years ago. Are you referring to that, or you're just saying this because you've been there and you think it's really cool? Because it is very cool. Yeah, let's find that stream. There we go. Around in here, and yeah. But anyway, good stuff. Everybody's saying hello to you too. So and thanking you for. There we go. I wasn't totally sure this was going to work technology-wise, and then it did. I was so pleased with this. Excellent. Okay, it's working again. Beautiful. Perfect. Okay, I guess it just needed to be restarted. Well, welcome everybody back to Paleontologizing. And again, we're here at Berlin Ichthyosaur State Park. And the nearest town to here would be what, Gabs, Nevada? Yeah. This is Jeff Morris here, who is the park supervisor, right?
Correct.
He's very graciously agreed to take us on a little tour today. So cross your fingers that that everything works properly. We've got the Starlink router and my battery pack right there. Hopefully the signal reaches throughout the whole building. It's like, I don't know, hopefully it just kind of bounces around in here. And yeah. But anyway, good stuff. Everybody's saying hello to you too. So and thanking you for yeah, this is pretty awesome. So it lifted up, you know, this used to be the an ancient seafloor. There's multiple giant ichthyosaurs preserved in here, still in the ground, in situ, where they've been for over 200 million years. Making the excavation so much more complicated.
And up here, the Earth is always moving. So.
Exactly. Yeah.
Reno just had an earthquake last night.
Oh, did they really? Yes. Oh, shoot! It wasn't a big one, I hope.
It wasn't too bad. No.
Okay. But yeah, Basin and Range Province, you know, it's.
So here we find specimen 6. This one's a good example of how long the rib cage was.
Look at those ribs there.
You see a cone of vertebrae. You see how they crack and weather.
Yeah.
Left untreated or exposed to the illness. If this building wasn't here, it would just turn to dust.
Right.
All of this fragmented bone that you see is part of the rib cage. They weren't able to save it.
Okay.
But they saved it over here at R, and they poured the slab of concrete to hold it in place.
Right.
So now you can see how long.
Anyway, here is a link to this VOD if you'd like to watch it. This is a really fun stream, and really glad that all worked out, you know? Yeah. Yeah. Why do they have so many bones? Yeah, ichthyosaurs do this crazy thing where they like multiply the number of bones in their flippers and stuff like that. It just worked out that way, I guess. Yeah. So if you look at their flippers, you know, we've got how many bones in our fingers? So we've got carpals, metacarpals, and then phalanges. So it'd be like 1, 2, 3 bones, and your index finger. These guys have got so many. It's like 20 per finger. 20 bones. And they just do this. It's interesting stuff. Yeah. There's a name for that. I forget what it is, but it'd be cool to be able to talk to somebody like, well, Josh Lively would be able to tell us about that. Mosasaurs, I think, do something similar too. So, if you look at something like Tylosaurus, yeah, they've got more than your typical number of phalanges in each of their digits. Yeah, it's cool stuff. Yeah. Marine reptiles, they're so cool. They're so cool. I'm excited to be able to talk about marine reptiles, living marine reptiles tomorrow during this meeting in Monterey. But yeah, yeah. And marine mammals don't do this, right? You know, I'm not sure, Claire, actually. Maybe they do. If we look at something like a gray whale, I don't think they do, actually. Yeah, I think they're pretty conservative with the number of bones on their fingers. This is a gray whale skeleton here. No, maybe they do. In some of their digits. I'm not totally sure. Yeah. I'm not sure how many of those are phalanges and how many of them are metacarpals. But I wouldn't be shocked, actually, if whales do this. Yeah. And that's a humpback? I guess that is a humpback right there, huh? Yeah. But yeah, like a gray whale, they're going to have shorter phalanges. But yeah, humpback whales have got huge flippers. Their foreflippers are enormous. That's where their genus name comes from. Megaterra. Means big wing, I guess. Because those are almost like wings. Yeah. But not nearly the degrees marine. Exactly, Claire, yeah. Yeah. Anyway, cool stuff. So again, here's a link to that coelacanth press release. You can get to the paper from there if you would like to. But, good stuff. Let's move on to our next piece of fossil news. Because again, we've got just an hour to go through the rest of these. Holy cow. Let's continue with our marine reptiles here. We've got a new species of sea turtle here from the early Cretaceous. Early Cretaceous fossil in Swiss museum found to be a new species of marine turtle. Crespedochelys. Paleontologists have described a new species of the extinct turtle genus Crespedochelys based on a remarkable fossil shell and some of its postcranial bones from Colombia. Very nice. Crespedochelys renzi lived in the Hoderivian age of the early Cretaceous between 132 and 125 million years ago. So the Hoderivian is here. That's pretty early on, actually. There we go. So this is not too long after... I think this might be roughly the same time as the fossils I'm going to be digging up at the end of next week in Utah. Yeah, I don't know if it might even be Barremian, so this might be earlier than those fossils that we're digging up. But anyway, this is from the Hoderivian. This ancient species was a type of Thalassocoletian, a group of marine adapted turtles from the Jurassic and Cretaceous periods. This is not part of the modern sea turtle families. This is not a dermochelid, like a leatherback. Right here. It's not... Here we go. Actually, this might be... Nope. We will go with this. Yeah. It's not part of... You know what? Hang on. I'll just pull this... I know where I got this image. There we are. Beautiful. So this is a phylogeny, an evolutionary family tree of modern sea turtles. I can show you a different view on one zoom. We'll zoom in there. There's lots of different ways that you can illustrate a family tree like this. They might be showing identical information, but there's just different ways to show it. So here we've got this tree of life that's, you know, kind of a fractal shape, and, you know, you get these curvy branches like this. This is one way of illustrating it. This is another way of illustrating it like this. You know, different appearances for different purposes. But here you can see that all modern species of sea turtle are either endangered or threatened. They're all at risk of extinction. I think this is basically showing the same information. Leatherbacks, dermacheliids, are their own family. There's only one species in this family, Dermacheliidae. See that right here. The leatherback, Dermacheles coriacea. Then you get the green turtle and the flatback turtle. And these are each other's closest living relatives right here. And then you get the olive ridley and Kemp's ridley here, which, according to both of these trees, are each other's closest relatives. The ridley sea turtles here. Genus Lepidocheles. I think this has actually been called into question. I don't know what the modern consensus is on this. This is what both of these trees are showing, though. So these are members of the same genus, so they're each other's closest relatives. Outside of that, you get the loggerhead and then the hawksbill. Loggerhead and hawksbill. See how that works? Yeah. Anywho. This new fossil species of sea turtle does not belong to this group at all. It is a separate kind of turtle that independently evolved to be ocean-going. It evolved to be a sea turtle. It's outside of this modern group of sea turtles, as far as I understand, which is really cool. So Thalassocolidia is the name of that group. There we go. A clade of extinct marine turtles from the late Jurassic and earliest Cretaceous of Europe and South America. So here we go. It includes all of these critters here. Pretty neat. Here's one of them right there. Solnhofia from the Solnhofen, right? Yeah. Pretty neat. And that is something to be proud of, KDR. Absolutely. That's really cool. It's really important that we protect critters like sea turtles, because they are all at risk of extinction. Every single living species, all 7 of them. Including the flatback turtle. I don't know why this one is not red, but they are also at risk of extinction, as I understand it. Anywho, Crispetocheles lived during the Hoderivian of the early Cretaceous. It's a type of Thalassocolidian, a group of marine-adapted turtles from the Jurassic and Cretaceous. Throughout their evolution, various unrelated groups of turtles had developed adaptations to live in marine and littoral. Littoral means like coastal, so like shallow water near the coast environments. Said Dr. Edwin Alberto Cadena, paleontologist at the Universidad de Rosario, Smithsonian Tropical Research Institute, and Field Museum, and his colleagues. One of these groups is called the Thalassocolidia, formed traditionally by 3 Jurassic families: Eurysternidae, Plesiochelidea, and Thalassomidae, with unresolved and controversial phylogenetic relationships. And we see that right here, where you've got like a big polytomy right here. where it's like all of these guys, who really knows who's closest to whom? Same with here and here. It's still pretty mysterious how these guys are related. The shells of plesiochelys can be distinguished from the other thalassocolidians by exhibiting large sizes, the absence of a carpacial fontanelles in adults, an osseous bridge, and at most, a central plastral fontanelle. So anyway, the fossil specimen of this new species, Crespedochelys renzi, was initially discovered by the Swiss geologist Otto Renz during a fieldwork expedition to the Cunha de Cuiza region, Guajira department of Colombia in the 1950s. So this critter was originally discovered in the 1950s, 70 years ago, and only now has it been recognized as a new species. It's pretty cool. And Danae Raven, hey, you sleep well. Thanks for being here. Yeah. And Solnhofen, that is exactly where Archaeopteryx and Compsognathus are from, Compsognathosaurus. Yep. We'll be talking more about Solnhofen in a little bit when we get to this new pterosaur paper. But yeah. Yeah. The specimen included a partial shell, hind limb bones, and caudal vertebrae. So it was housed in Switzerland, where it remained forgotten for more than 60 years in the cabinets of fossil invertebrate collections. Invertebrates, what? This is the youngest record known so far for thalassocolidians worldwide, from the Hoderivian, the second record of the group outside of Europe. So this extends their survival of this group. We didn't know that they survived this late in time, which is exciting in and of itself. It represents a significant contribution to the understanding of thalassocolidia, particularly the plesiochelid turtles, extending their geographic range to northern Gondwana and their temporal range into the Hoderivian, the researchers said. This finding underscores the importance of reevaluating historical collections and highlights the potential for future discoveries in underexplored regions like northern South America. Exciting stuff. So again, just like the previous paper about those British coelacanths, that showed that these specimens that had been sitting in a drawer for like 150 years, misidentified as fossil marine reptiles. It turns out they're actually coelacanth fossils. Here's a fossil sea turtle from a weird group of now extinct sea turtles. This had been kind of ignored, forgotten for a long time. Turns out it's a new species. And it extends the temporal and geographic range for that entire group. This was a discovery that was made in a museum drawer. Well, I mean, originally it was discovered in the field. Fieldwork, again, is the foundation of paleontology. But museum work like this, you could make new discoveries in a museum, too. It's really cool. Yeah. Pretty neat. So the presence of Crespedochelys renzi and the Moina Formation further emphasizes the complex paleobiogeographic history of coastal and marine turtles during the early Cretaceous. It also offers new insights into the evolutionary dynamics of Thalassocolidia and the still controversial and unstable phylogenetic relationship within the group, issues that warrant further in-depth investigation in future studies. So it's like, wow, here's this cool new weird thing. It's causing us to rethink our understanding of this particular group of turtles. And it goes to show how one new find like that can kind of change the game. As I understand it, the phylogeny, the evolutionary relationships of Mesozoic sea turtles is kind of in flux. New discoveries keep changing things. And that's exciting, you know? So this is in the Swiss Journal of Paleontology. We'll see if that's open access or not. And holy cow, it is indeed open access.
Access granted.
Here is a link to that paper right there. There we go. Good stuff. So we probably saw their coolest figure already, but we'll see. This is neat. I love this paleo map right here, though. This is showing as this animal was alive, this is how the continents were arranged. There it is right there. What's neat is that, like, as the continents split apart, as Pangaea breaks up, you have Laurasia and Gondwana. Laurasia in the north, Gondwana in the south. These two supercontinents, they start to break up too, and as they do that, there's more and more and more coastline. There's more potential for nesting habitat for these creatures, and that does seem to maybe correlate to the diversification of sea turtles during the Cretaceous. It's pretty neat. Because with more beach, you get more places to lay your eggs. And these critters seem to thrive during that. You get these different groups of sea turtles that evolve and diversify. There's the specimen right there. Here's where it's from, in Colombia. On this little peninsula of Colombian land up there. Yeah, nice. Very cool. It would be neat if they had a life reconstruction of this animal, like what it would have looked like when it was alive, but I don't know if... Oh, they do! It's beautiful! Look at that! Well, I guess we should have expected this from the press release. Really nice. It kind of looks like it's new to the ocean here. The way they illustrated it, you can still see these kind of grooves in between the fingers and the flipper. It's almost like these guys they're kind of new to having flippers, you know? Just a few million years prior, they may have still had separate fingers, but they've only recently developed into a paddle like this. That's really cool. Yeah. And so it might occur in North America? I don't know, Claire. I don't think so, since this is from the earliest Cretaceous. There was no big inland sea in North America yet. Again, this would have been, let's see. This would have been around this time. A little bit earlier than this, actually. Yeah, like between here and here in time. Yeah, so this is from northern South America. This is before North America gets bisected by the Western Interior Seaway. That would be later, like this. And then like that. This is when you get... This is like the heyday of North American sea turtles. It's during the Western Interior Seaway time like this, in the late Cretaceous. So it's before this time. Again, it would have been more like this. Yeah. So, so we're not going to find them in Doling's Bowl. Absolutely not, Claire. No, because at this time, Utah was very much landlocked, just like it is today. Yeah. But just outside of Doling's Bowl, just a couple miles away, really. Very, very close. You get the Mancos Shale. There you go. And so this is marine. So this is from toward the beginning of the late Cretaceous, the Mancos Shale. And this is where you get plesiosaurs, mosasaurs, sea turtles, ammonites out the wazoo, all kinds of invertebrates. These grayish rocks like this that just seem to kind of be melting, they erode really quickly, the Mancos. And when it rains, they just turn to muck. Just impassable, snotty mud. Yeah. Important stuff. This is where Josh Lively does a ton of his work, is in the Mancos, and I'm sure we'll be talking about that at some point when I'm out there in the field with him. But yeah. Jim just recently published a big publication on the Mancos. And, there we go. And he was honored with an award. The 2025 Crawford Award. To James Ian Kirkland. in recognition of his study in the Mancos Formation, culminating in the outstanding publication Revisiting the Cretaceous Mancos Group in Utah, Problems, Previous Methods, and New Perspectives on a World-Class Marine Cretaceous Section, Geology of the Intermountain West. Very cool. And, yeah, I congratulated Jim about this earlier. I don't know if this is available to the public yet. There was the event there, which is now done. This is this past May. I think I was just coming back from Puerto Rico at the time, so I didn't get to go to this. But, yeah, you can request a copy direct from the authors if you really want to. There you go. Yeah. Oh, you mean the Blue Sky post? Okay, here you go, Claire. Yeah, if you'd like to congratulate Jim, there you go. But anyway, back to earlier times, the Hoderivian. Because the Mancos Shale is what age? I know it's Upper Cretaceous, but what's the particular age? What geological age are we talking about? Cenomanian. There we go. Could have known that off the top of my head. But here we go. So the Mancos is from the Cenomanian up here. Cenomanian. Our new fossil sea turtle from this new paper is from the Hoderivian. So it's like 30 million years older. Yeah. So this critter here is about 30 million years older than any of the stuff in the Mancos. Yeah. Good stuff. Anyway, really neat. And it goes to show just like the diversity of ancient sea turtles during the Mesozoic. When you say sea turtle today, you're referring to this group, the Chelonoidea. But there were other groups, not necessarily close relatives, of sea turtles that existed during the Jurassic and Cretaceous periods too, which is really neat. This form of animal with a shell like that and the four limbs, usually flippers, it's evolved multiple times, and not even always within turtles. Again, when we're looking at our ancient sea reptiles book here, I've been showing off today, you get these weird things like Henotus, these weird marine placodonts that are not turtles. So even though this looks like a turtle, it is not a turtle. This is a different group of reptiles with different ancestry. They're in a completely different spot on the tree of life, on the reptile family tree. There's Siamotus right there, which is... oh man, they're weird and cool. So yeah, it's they're really neat. So this kind of body plan has evolved multiple times in multiple different groups of reptiles, not only just in turtles, but in critters like placodonts too. Pretty awesome. So this is one of the most turtle-like of the placodonts, the caption says. Several features of the Siamodontid carapace look hydrodynamic, and might be that some of these animals were speedy swimmers, as implied here. Yeah. Pretty neat. So yeah, cool stuff. Yeah, placodonts are bizarre, just fascinating animals. That their heyday was the Triassic, and they did so many cool, weird things. Placodontia. You have these barrel-chested ones, like, I think this is Placotus right here. And they have these extremely weird, blunt, crushing teeth, probably for crunching up mollusks. I should really 3D print a skull of one of these guys, because I have the files for it. They've got these super bizarre, protruding, pronathous teeth like this in the front. And then their back teeth are just these round, crushing knobs like that. Just for crunching up shellfish, you know, mollusks and what have you. And they've got, like, these big platy teeth, like, on the roof of their mouth. So, right here... this, what you're looking at here, is the roof of the mouth right here. So this is a ventral view of the skull. And so look at that. Just these big crushing plates on the roof of the mouth. Palatine molars is kind of, Claire, yeah. Yeah, I wouldn't call them molars per se, because molars are a mammal thing. But yeah, look how weird and cool that is. They're so strange. So that's Placotus there. And, yeah, it's bonkers, right? They're such weird animals. And that makes me realize, shoot, we should pull up, oh, hi, Sweetie Pie. Here. Let's pull up this critter in my 3D printing folder. Oh, Sweetie Pie. Hang on. There we go. This might be a little bit too big to fit on the print bed, but we'll see. I can at least show you. This is the skull of that critter right here. And this is a sculpt. It's not like a scan. It's a little bit too perfect for that. Or maybe it is. I think parts of it have been reconstructed. Like there's plaster and other stuff in there. But anyway, just beyond cool. Like, what a weird animal. Yeah. Super, super neat. Sweetie Pie, what are you up to, huh? What's going on with you? Huh? What are you looking for? What are you looking for? Huh? You want some treats, huh? Look at these. See, Mini Pie left some crumbs for you, and Sweetie Pie's like, I don't want crumbs. It's time to pay rent. Tenant. Okay. Okay, Sweetie Pie. Okay. Yeah, alright. Alright. Ooh. How's that? Good stuff? I know Charlie's Dragon. Crumbs. Why do I insult her like that? I'm sorry, sweetie. I'm lucky you don't eat me. Yeah, well, I'm asleep. It'd be so easy, too. Boy, I gotta keep you well fed. So you don't feast on me while I'm unconscious, huh, Sweetie Pie? Yeah, you little hyper carnivore. Steal your breath. There you go, Pfizer, yeah. Yeah. You gotta stay on your good side, huh? Yeah. It's a good thing you just want treats and cuddles and not, you know... You're not gonna dine upon my unconscious body, huh? Huh, Sweetie Pie? I shouldn't be giving her ideas. Look at this beast. Yeah, You want more? She's like, that's not enough. You want some more, sweetie pie? Yeah? Oh, look at that chin. Look at that chin. Yeah. It's unsporting to get you while you're sleeping. You will be awake and know she is coming, says Claire. Is that true, sweetie pie? I don't think she's that concerned with the dignity of the hunt or anything. I think sweetie pie just wants to eat. Huh. Yeah, you don't even think about that. Huh. You want some more? You want some more? Okay. Okay. You twisted my arm. Oh, there's so many. Too many. Put these back. Ooh, good stuff. The cat won. Oh, that sounds cool, Pfizer. It sounds like that movie Mouse Hunt, but with a cat instead. Yeah. It's good to hear those crunches, sweetie pie. Working those chompers. Not quite as chompy as these teeth. I mean, here, let's do a little thing here. And I'll dissect this skull for you so we can look at those chompers. Deep upper part. There we go. There we go. Look at those crushing palatine teeth there. I don't know if these are actually true socketed teeth or if these are just like weird osteoderms or whatever inside the skull. I'm not super familiar with placodonts, but yeah, pretty neat, you know? Yeah. What a cool creature. Just awesome. Yeah. And cats with successful predator. Yeah, of course. Yeah. Oh, I'll see you later, sweetie pie. Yeah. Anywho. Where were we? Oh, yeah. New sea turtle species. Cool stuff. Very cool. So let's move on from that. And one more time, here's the link to that press piece right there. If you'd like that. With half an hour left, we've got 3 more papers. So let's get into those. Let's talk about another marine creature, but we'll go outside of tetrapods. We'll go outside of bony vertebrates. Here, we'll go to our tree of life, and let me take a little tour. Go to the sauropsids here. There's our reptiles like we've been talking about with our sea turtle. That's a kind of reptile, a kind of sauropsid. So we're going to be leaving Sauropsida, leaving Amniota and Tetrapoda, and lungfishes and tetrapods, and lobe-finned fishes. This is where we rendezvous with the coelacanths here. We're going to be going to another kind of creature. It's not even a bony vertebrate. We got to go further than that. We got to go to the jawed vertebrates. So which group of creatures is within jawed vertebrates, but it's not a bony vertebrate? Which group of creatures are we talking about here? Which group of animals has jaws but doesn't have bony bones? Yes to jaws, but no to bony bones. Who are we talking about here? And you totally got it there. It is indeed the cartilaginous fishes. Chondrichthyes, which includes the elasmobranchs, which includes the sharks. Right here. Here we go. So the headline is, sharks now roam the open ocean, but for 200 million years, they only lived near the seafloor. And Arsenic 8, hey, thank you for the follow. Welcome to Paleontologizing. Here's a link to this right here. And sharks have cartilage, not bones. Yeah, well, they have bones that are made of cartilage. They're not made of, like, hydroxyapatite bone. It's interesting how that works. But yeah. And that looks like a tiger shark there, doesn't it? Does this look like a tiger shark to anybody else? It reminds me of that.
What kind of a shark is it? Gee, I don't know. I think it's a macaw. Got a deep throat, Pratt. Yeah, but what kind? What kind of shark?
It's a tiger shark. A what?
A what? I'm pretty sure that's a tiger shark, but I'm not 100% sure. Yeah. So when you picture a shark, you probably think of a large, powerful predator cruising the open ocean. Species such as the great white shark, tiger shark, and bull shark dominate popular media, with stories of rare and isolated cases of attacks on humans. It's far more likely for a person to attack a shark than for a shark to attack a person. You're more likely to get killed by a vending machine than you are by a shark. Just by the numbers, you know? Yeah. So while these three species, what was it? Tigers, whites, and bull sharks, are certainly charismatic predators, they represent less than 0.6% of living sharks. The more than 500 species of living sharks exhibit an astounding diversity of shapes and sizes, from giant 20-meter-long whale sharks to phone-sized bioluminescent lantern sharks, flattened angel sharks, hammerhead saw sharks, goblin sharks, and wobbegongs. But how did sharks become so diverse? A new study I led, this is not me, this is Joel Gayford. A new study I led investigated the evolution of body shape in sharks from their ancient ancestors more than 400 million years ago. This is around the same time as the first coelacanths, all the way to the present day. A time before the dinosaurs. The huge variation in body shapes we see today did not appear overnight. The shark lineage traces back to a time before the dinosaurs. Scientists often use fossils to recreate shifts in body shape and size across the evolutionary tree of different animal groups. Unfortunately, we can't do the same thing with sharks. Why do you think it's difficult to find out the body shapes of extinct sharks, fossil sharks? Why is it tricky to figure out what their body shape was? What do you think? And once again, you guys are on it. This is excellent. Cartilage doesn't fossilize well, if at all, says Catherine's Worf. Yes. Their skeleton, VHS James says. Yes. Dr. Terminator says, whoops, all tooth taxa. Pretty much, yeah. And the occasional vertebra you get here and there as well. That's because shark skeletons are made of cartilage instead of bone. So unlike mammals, birds, or reptiles, we don't have many complete fossils of ancient sharks. Instead, we have loads and loads of isolated fossil teeth. There you go. This means that until now, scientists have known very little about how, when, and why the huge diversity of shark body types we see today evolved. So figuring out the evolution of different shark groups is tricky when you mostly only have teeth to work with. And teeth can trick you. You can have different groups of sharks that evolve similar kinds of teeth. It's a little tricksy. Instead of using fossils, We collected information about body shape from scientific illustrations of more than 400 living shark species, and used a statistical method called ancestral state reconstruction to estimate the body shape of ancient sharks. Interesting. This is a paleontological study that's not looking at paleontological remains, not looking at fossils? Huh. Interesting. We also collected information about the habitats that different shark species prefer and how environmental conditions have shifted since the emergence of the very first sharks. So ancient sharks were bottom dwellers. Our analyses suggest that ancient sharks were probably benthic, meaning they lived on or close to the sea floor. Pelagic sharks, these are ones that are like open ocean critters. Pelagic sharks that roamed the open ocean and resembled today's large iconic predators such as great white, tiger, or bull sharks, did not arise until the Jurassic period, 145 to 201 million years ago, at the very earliest. This means that, for the first half of their existence, sharks were restricted to habitats close to the sea floor. Interesting. So, sharks have been around for a very long time, or at least elasmobranchs have, this broad group that includes sharks. So, yeah. Chondrichthyes, they've been around for about 420 million years ago. So for about half of that time, from 420 million years ago until 225 million years ago, or thereabouts, sharks were mostly bottom feeders. Or this group of animals, Chondrichthyes, which includes modern sharks. These creatures are kind of restricted to the sea floor, or thereabouts. Why? Interestingly, we found that all three of the 4 times sharks have colonized the open ocean, there was a shift in body shape, including the evolution of a deeper body with more symmetrical tail that occurred just before the shift in habitat. The timing of these shifts also indicates historical climate change, including rising sea levels and tectonic shifts may have played a crucial role in creating more pelagic habitats these sharks could have colonized. This means that as the climate changed, so too did the habitats that these ancient sharks inhabited, enabling the evolution of new body shapes. As it so happened, these deeper bodies with more symmetrical tails were better suited to open water living. So what we're talking about here, I'll see if I can hopefully illustrate this for you. So here's Carcharodon carcharocles, the white shark here. See how its body is kind of, if you were to look at it from the front, it would be like round in cross-section. It's a thick critter. And it's kind of like a nice curve all the way around, you know? Kind of torpedo shape, bullet shape, Charlie's Dragon. Yeah, there you go. Most sharks are not like this. This is a pelagic shark, so a shark that inhabits the open ocean. It's not going and bumping up against the seafloor. It's not going up near the beach most of the time. This is an open ocean predator. This is way out in the middle of the ocean oftentimes. Compare that to, say, a leopard shark. These guys have got kind of a flatter belly. See how they're not round all the way through? They've got kind of a flat surface on the bottom. So flat, says Claire. I know, right? So that's because these guys are mostly hanging out on the seafloor. They like to hang out in kelp forests and even like estuaries and stuff like that, but they're hanging out near the bottom. This is not a species that you're going to see way out in the middle of the ocean where the ocean floor is thousands of feet. You know, they're not hanging out there in the water column. They're not a pelagic species. Does that make sense? Were you picking up what I'm putting down? Yeah. Nurse sharks also. There you go, Pfizer. Yeah. Yeah. So a nurse shark. There you go. They've got kind of a flat belly too. They're hanging out on the bottom, like you see in this illustration. They're flat underneath. They're not that torpedo shape, you know? So yeah. So yeah, the evolution of a deeper body and more symmetrical tail is correlated with being pelagic, being out in the open ocean. So this means that as the climate changed, so too did the habitats these ancient sharks inhabited, enabling the evolution of new body shapes. And it so happened that these deeper bodies with more symmetrical tails were better suited to open water living. By looking back in time at what ancient sharks looked like and how they might have lived, we can better understand how ancient ecosystems functioned and predict how they may respond to future human-made climate change. More broadly, these results showcase that not all sharks are the same. Most sharks, both ancient and living, are small and benthic, not large, dangerous apex predators. So the next time you picture a shark, think not only of great whites and tigers, but also of the ancient bottom dwellers that shaped the seas long before the first dinosaurs. There you go. Here is the paper right here. And it is once again, oh man, we're getting lucky today, open access.
Access granted.
Here's a link right there in the chat for you. Yeah. Good stuff. Habitat availability, Jurassic and Cretaceous origins of the deep-bodied shark morphotype, and the rise of pelagic sharks. Very cool stuff. Really neat. Do we have any good figures here? Kind of a scatter plot right there. Okay. Geometric morphometrics, I guess. There we go. There's a phylogeny there with these different points like we saw in the other figure. It'd be cool if they just had like a simple figure where it's like, here's our different body shapes. Here's what they look like in cross-section, but I guess they didn't put that in here. If I were an author on this paper, I would have pushed for some better figures. But yeah. Cool stuff. Very cool. And now we've got 2 more papers to do? Alright, let's go really quickly through this. Digging into the origin of lizards, ancient fossils show only one of 3 predicted ancestral traits. Pretty neat. Oh, that's neat, Kaklanzorf. Benthic sharks don't have that kind of sensitive, huge cerebellum. Huh! That's cool. That's really cool. All right. This just came out today. Digging into the origin of lizards. Ancient fossils show only one of 3 predicted ancestral traits. And this might look like an AI image. It is not. This is an illustration by Bob Nichols, who's the same guy who did that that stegosaur illustration. You might remember this from a couple weeks ago. Remember this illustration from that video? Yeah, beautiful one. Bob Nichols did this. And he did this. Good stuff. A new fossil from Devon in the UK reveals what the oldest members of the lizard group looked like. And there are some surprises, according to a research team from the University of Bristol. Study is published today in Nature. Wow. Nature, you say? Good for them. High-profile journal. Today, lizards and their relatives, such as snakes, together with the unique Tuatara from New Zealand, are the most successful group of land vertebrates with over 12,000 species. So, what we're talking about here is Lepidosauria. This is a group of reptiles that includes lizards, including snakes, and also the Tuatara, too, which are not lizards, but they're outside of this group. So here's squamates. So squamates plus Tuatara. Their powers combined, they are the Lepidosauria. Right there. But what is it about lizards, snakes, and Tuatara, collectively called Lepidosauria, that has made them so successful? It was always expected that the first lepidosaurs would have had some of the lizard characters, such as a partially hinged skull, an open lower temporal bar, and abundant teeth on the roof of the mouth, or palate. These are all features of modern lizards and enables them to manipulate large prey by opening their mouths super wide, skull hinge, and using teeth on the palate to grasp wriggling small prey. So by looking at all of these modern lepidosaurs, we can kind of make some guesses as to what their ancestor would have looked like, because we can find all these traits that today are really important. We can try and turn back the clock in our imagination to try and figure out, try and picture what an ancestral lepidosaur would look like. So we can have a hypothesis there, and we can test that by going into the fossil record, finding more fossils of these critters, seeing if our guess is correct. And in this case, it seems like the guess wasn't entirely correct. Oh, I like this song, but I've got to talk over it, so let's skip it, because there's lyrics in that song. Lower temporal bar is essentially the cheekbone. Snakes and lizards have all these features and some additional flexibility to the skull. Only the tuatara has a complete lower temporal bar, giving it an archaic look, reminiscent of some of the earliest ancestor reptiles. Has some large palatable teeth. The new fossil shows almost none of what we expected, said Dan Markey, who led the project as part of his studies for his master's in paleobiology at Bristol. It has no teeth on the palate, and no sign of any hinging. It does, though, have an open temporal bar, so 1 out of 3. Not only this, but it possesses some spectacularly large teeth compared to its closest relatives. In modern paleontological studies, we often X-ray the fossils, added Dr. David Whiteside, co-supervisor of the project, but the exceptional resolution and quality of scans for synchrotron X-ray sources show us all the fine details and save any risk of damage. An earlier master student, Thediwoot Sethapanishsakul, had worked on the regular scans and found fantastic detail, but that's so tiny. The skull's only 1.5 centimeters long, you could barely see the teeth, so we were so grateful to be able to make synchrotron CT scans to get even finer resolution, using 2 powerful beam lines at the European Synchrotron Radiation Facility in France and the Diamond Light Source in the UK. When you look at the fossil, the whole skeleton sits in the palm of your hand, explained Michael Benton. Michael Benton, Jim mentioned him earlier in the chat. He was also an author on the coelacanth paper. Yeah. But after the scans and the hard work of our students cleaning up the scan data, we can see the most amazing detail. The new beast has a relatively large triangular-shaped teeth and probably use those to pierce and shear the hard cuticles of its insect prey, pretty much as the tuatara does today. This new animal is unlike anything yet discovered, and has made us all think again about the evolution of lizards, snakes, and the tuatara, said Dan Markey. We had to give it a name to distinguish it from everything else, and we chose Agriodontosaurus helsbypetrae, quite the mouthful, meaning fierce-toothed lizard from the Helsby Rock, after the Helsby sandstone formation in which it was discovered. This specimen not only provides important information about the ancestral skull of all lepidosaurs, but also builds on the growing knowledge that the tuatara, which we often call a living fossil, belongs to a once diverse order of ancient reptiles with a rich evolutionary history. The fossil dates back 242 million years in the Middle Triassic, just before the dinosaurs appeared. And since then, the lepidosaurs have diversified in several stages. The early ones flitting in and out of the undergrowth under the feet of the dinosaurs. They owe their success to their amazing ability to capture insects and other prey using a variety of remarkable adaptations, including their highly flexible jaws and, in the case of some snakes and lizards, use of venom. When I found the specimen back in 2015 on a beach in Devon, I had no idea what it was because there was so little of it exposed, said Dr. Rob Coram. It's been great to see such an amazing fossil come from a site that has provided fossils for 150 years. So here is the paper right here in the journal Nature. And lucky for us, it is once again open access, no paywall, We're what, 4 for 4 so far? Not too shabby. Yeah. Here is a link to the paper right there in the chat for you. Beautiful. The oldest known lepidosaur and the origins of lepidosaur feeding adaptations. So this actually, here's a callback to last week's streams. Last Wednesday, we were talking about different scientific journals with Rhacodactylus. And I mentioned these really high-impact journals, the journal Science and the journal Nature. And both of these, when they're publishing, when they choose to accept papers from paleontologists, it's usually like, here's a really cool new critter. That's really important for some reason. Really novel, really interesting. This is one of these. It's a superlative. The oldest known lepidosauria. The oldest known member of this group, Lepidosauria, which includes the Tuatara and all the lizards, including snakes. Squamates. So there you go. This is exactly the sort of thing that Nature is interested in, so yeah. As a journal. Very cool stuff. So there you go. Pretty neat. And so since this fossil was so small, they said it could fit in the palm of your hand, rather than mechanically preparing it, rather than like chipping away the rock with dental picks or something like that, this thing is so small and delicate, they had to just scan the whole thing, shove it into a synchrotron scanner, and this is what they've got after all the digital preparation. So like, these scanners are really powerful, but they're still going to give you an output file that's hard to interpret. You need to like digitally remove the rock, essentially, in the file. That takes a long time. Fisher McDarmid, friend of the channel, personal friend of mine, this is what he spent much of his undergraduate career doing, is digital preparation like this. So it's, yeah. It's cool stuff. And here's the reconstruction. Look at this doofy face right there. Look at this. Look at that critter. Oh, that's funny. Oh man, what a weird animal. Very cool. So there's a reconstruction of the skull. Different skull bones labeled right here. This is cool. This is very cool. And it is coming out as basal to all the other lepidosaurs. There it is right there, highlighted in red. Or the text is in red right there. Agriodontosaurus. Very cool. There's other groups of reptiles. There's the placodonts, like we were talking about earlier. There's, who is this? Rhynchosaurs, I think, over here. There's Rhynchocephalia over there. And then you get the squamates. Pansquamata right here. Lizards and snakes. Yeah. Good stuff. Anyway, very cool. It would be neat to see what Laura from Cambridge, who was with us in the field in Doling's Bowl this year, what she would say about this. This is interesting stuff. Very cool. Yeah. So we speculate that, like Sphenodon, like the Tuatara, Agriodontosaurus was a lingual feeder that used its tongue to manipulate prey in the mouth, placing it between the large marginal teeth. So it's probably doing, I love that emote there, Golganek. Yeah, that Lenina emote, that's excellent. But they will use their tongue to catch buggos and stuff like that and eat them up. There's one eating a weta, which is kind of one of the symbols of New Zealand. But yeah. So they'll use their tongue a lot as they're feeding, and it's speculated that this new critter, which is potentially ancestral to Tuatara and to lizards, probably not this exact species, but some member of its milieu is ancestral to this group. Pretty cool. They're using their tongue the same way. Keen sight and hearing on the basis of relatively large orbits in the presence of the lateral conch of the quadrate, necessary for hunting fast-moving prey. Cool stuff. This is really neat. Congrats to the authors. Really neat. Important paper. Very cool. Very cool. Yeah. Good stuff. Well, there we go. There's 4 out of our 5 stories. Let's do our final one. Oh, and again, here's a link if you want to read about that on your own. Yeah. Our final piece of fossil news for today. 2 extraordinary fossils of immature pterosaurs killed by catastrophic storm found in Germany. Paleontologists at the University of Leicester have examined the 150-million-year-old fossilized skeletons of 2 highly immature Pterodactylus antiquus individuals with broken wings from the Solnhofen limestones of southern Germany. Their findings show how these creatures were tragically struck down by powerful Jurassic storms that also created the ideal conditions to preserve them, and hundreds more fossils like them. Yowza. So an artist's impression of a tiny Pterodactylus antiquus hatchling struggling against a raging tropical storm, inspired by fossil discoveries. This is by Rudolf Hema. That illustration is by Rudolf Hema. So Solnhofen, this is the same environment that that all of the Archaeopteryx specimens are from. Let's see, where was that? There was a documentary that we were watching a little while ago. This would have been here. There we go.
That question has intrigued the historians of life for more than a century and inspired one of the longest-running detective stories in science.
Here's Solnhofen here. So this is where these fossils are from.
Clues were found long ago in the Solnhofen limestone quarries of southern Germany.
Yep.
When polished, this stone shines like marble. It's been a prized building material ever since the Romans worked these quarries 2,000 years ago. The stone itself was laid down.
But what have the Romans ever done for us, you know?
140 million years ago, when this region was a tropical lagoon behind a barrier reef. Over a period of 500,000 years, countless layers of marine sediment settled to the bottom of the lagoon, slowly hardening to stone. In the late 1700s, the invention of lithographic printing created a huge demand for limestone. Production stepped up to meet the demand, and unexpectedly opened a window on the history of life when the quarrymen began to find unusual images in the stone.
There we go. This is the kind of preservation you get at Solnhofen. Just incredible,
Such things had been seen before, though never understood. But in the late 1700s, scientists were just beginning to grasp the great antiquity of the Earth, and fossils were recognized as messages from the deep past.
Look at that fish. Lovely. Look at that turtle.
At the time.
So this might be Solnhofia. There was that turtle that came up earlier. This might be it right here. Yeah, that might be it. Solnhofia. This might be an adult. But, named by Gaffney in 1975. It's a famous turtle paleontologist. There's a whole conference that's named after him, Gaffney Fest, on fossil turtles. Anyway, this might be the same critter.
No one realized just how deep the past was. That these were pictures of life, 140 million years old. That ancient lagoon had been a perfect fossil-making environment. The ultrafine sediment captured victims quickly and recorded them in extraordinary detail.
It is extraordinary. Just this brings a tear to your eye. You know? Incredible.
One day in 1783, a fossil turned up that was like nothing ever seen on Earth before.
Pterodactylus!
It was the size of a small bird, but it seemed to defy placement in any animal group then known. Georges Cuvier, the renowned French anatomist, finally made the correct identification some 20 years later. The skull, claws, and other features were those of a reptile, he said. But the strangely elongated fourth finger must have supported a wing. He named it pterodactyl, wing finger in Latin.
Yep.
Soon another fossil from the quarry proved him right. A beautifully preserved pterosaur wing with the impression of a membrane.
That skin membrane's still there.
A flying reptile was an idea so bizarre, it was hard to believe that such a thing had ever existed. But the limestone quarries kept turning up new evidence of what became known as pterosaurs, winged lizards.
Pretty awesome. Yeah, they're not lizards, but they are reptiles. Yeah. This is what we're talking about here. That's what this new paper is about. And here lies a mystery. While Sonthofen has yielded hundreds of pterosaur fossils, nearly all are very small, very young individuals, perfectly preserved. By contrast, larger adult pterosaurs are rarely found, and when they are, they're represented only by fragments, often isolated skulls or limbs. This pattern runs counter to expectations. Larger, more robust animals should stand a better chance of fossilization than delicate juveniles. So what's going on here? Why do you have all of these delicate juveniles that should be harder to preserve? Why are you getting them and not robust adults? In the new study, the authors analyzed the fossil skeletons of two immature pterosaurs from Solnhofen. The two individuals belonged to Pterodactylus antiquus, a species of pterosaur that lived in what is now Germany during the Kimmeridgian age of the late Jurassic. So, Kimmeridgian is... Here we go, right here. So, not quite the very end of the Jurassic, but close to it. Here's the Jurassic period, or in the Upper Jurassic, the Kimmeridgian age. So this is like Lower Morrison age, I guess, but in Europe instead.
Him into a trap where we can destroy him without deadly lasers.
There we go. With wingspans of less than 20 centimeters, or 8 inches, these hatchlings are among the smallest of all known pterosaurs. Both show the same injury, a clean, slanted fracture to the humerus. Humerus is your upper arm bone right here. And it's a fairly short bone in pterosaurs, surprisingly. But, yeah, there it is. Right there, highlighted in red. That's the whole bone, there in red. The left wing of one individual and the right wing of another were both broken in a way that suggests a powerful twisting force, likely the result of powerful gusts of wind, rather than a collision with a hard surface. A hard surface, you just get the bone snapping, but this is like, it's sheared and twisted, it seems like. Catastrophically injured, the pterosaurs plunged into the surface of the lagoon drowning in storm-driven waves and quickly sinking to the seabed, where they were rapidly buried by fine limey muds stirred up by the death storms. This rapid burial allowed for remarkable preservation seen in their fossils. Like the two studied pterosaurs, which were only a few days or weeks old when they died, there were many other small, very young pterosaurs on the Solnhofen limestones, preserved in the same way but without obvious evidence of skeletal trauma. Unable to resist the strength of the storms, these young pterosaurs were also flung into the lagoon. This discovery explains why smaller fossils are so well preserved. They were a direct result of storms, a common cause of death for pterosaurs that lived in the region. For centuries, scientists believed the Solnhofen lagoon ecosystems were dominated by small pterosaurs, Dr. Smith said. But now we know this view is deeply biased. Many of these pterosaurs weren't native to the lagoon at all. Most are inexperienced juveniles that were likely living on nearby islands that were unfortunately caught up in powerful storms. A paper on the findings was published today in the journal Current Biology. So this highlights something that's really important to understand and remember when we're talking about fossil critters, is that just because an animal was preserved in a given environment, an animal or a plant, doesn't necessarily mean that it lived in that environment. And the stuff that we see in the fossil record isn't always a direct snapshot of like what was going on in that ecosystem. The fossil record can certainly be biased. You can get taphonomic biases that crop up in the fossil record. So just because a certain kind of organism might be really, really common, doesn't mean that it was the most common kind of organism around. There could be something leading to it being preserved more often. There could be something leading to that kind of bias, you know? It's the sort of thing you always got to be thinking about as a paleontologist. So this is published in Current Biology. And,
Stegosaurus.
thank you, Figment Pudding.
Long, weighing 4 tons. A versatile
6 months.
chap. He won a lot of arguments in his time, but very few beauty contests.
Paleo dance, 6 months of SCIENCE Paleo Science Shape.
Thank you, Figment Pudding, for the 6 months of support. I really appreciate that. Thanks for keeping me here online. Yeah. And Claire Burr says, Pipestone Creek probably didn't have a zillion ceratopsians all the time. No. So yeah, that's probably the result of like a catastrophic river crossing. Maybe it was a flash flood, something like that going on. But yeah, good point, Claire. Good point. So sometimes these exceptional fossil deposits are the result of exceptional circumstances. It might be a once in a millennium event that happened, or even more than that, you know? Stuff you got to think about, you know? Fatal accidents and neonatal pterosaurs, and selective sampling in the Solnhofen fossil assemblage. And what do you know? We are 5 for 5 with today's publications. Man, I love open access.
Access granted.
There you go. Here is a link for download right here. That is beautiful. It's
Triple! Oh, yeah!
not a triple, a quintuple today. Pretty exciting. All of our papers, open access. Gotta love it. Yeah. And I really like that Current Biology does these highlights like this. It's like an even briefer version of an abstract. And they have an in brief too. Like this is great. I really like this. Smith et al. Report wing injuries in neonatal pterosaurs. There's little baby pterosaurs. A term that I've actually heard applied to these animals is flapling. It's a made-up word. All words are made up. But yeah, a flapling. It's just a little baby pterosaur. Yeah. Yeah. So Smith et al. Reports wing injuries in neonatal or flapling pterosaurs from the late the Upper Jurassic Solnhofen assemblage, likely caused by storm events, and supporting precocial flightability. Precocial flightability, this means they're able to fly from a very young age. They're precocious in that respect. Almost as soon as they hatch out, they can fly. That's the idea. Taphonomic analysis, so this is like studying the conditions that led to preservation, basically. The forces acting on these critters before they actually got fossilized. Reveals predominantly storm-driven mortality and a strong juvenile sampling bias across most Solnhofen pterosaurs, highlighting how local environmental conditions distort the fossil record. Important to understand. Good stuff. And check out these little baby pterosaurs here. And I love that this is to scale. Here's a little pterosaur flapling, 2 of them actually, different specimens, compared to the size of a mouse. These are small, small, small critters. Yeah, mouse for scale. I know, right, Claire? It's so cool. Lovely. Yeah. And it's cool how much their skulls would change as they grow and mature, too. Their snouts really lengthen out like that. Yeah. Pretty cool. So normally, the skeletons of juvenile pterosaurs, and dinosaurs for that matter, like really, really small juveniles, tend to be rare. They might not have been that rare to be fossilized in the first place, but they're rare to discover, at least, you know? They're harder to find, certainly. Maybe not necessarily in a place like Solnhofen, but it's unusual that there's so many baby pterosaurs, and this might explain it. If the adult pterosaurs, the adult pterodactylists, are making it through these storms, if they're surviving, and the baby ones are selectively being killed, then that makes a lot of sense. They wouldn't have been as strong flyers, couldn't travel as far, as fast. Yeah, and neat illustrations here, too. This is really cool. Yeah. Huh. So under typical calm conditions, this figure is saying, Pterodactylus inhabits regions far from the lagoons. Yeah. So there's adults flying far out to sea, potentially, or into these lagoons. And under normal calm conditions, you've got more opportunity for the carcasses to break apart, to be scavenged, to be torn apart like this, which is why you mostly get isolated elements from the adults. That makes sense to me. But during fierce storm conditions like this, you have baby pterosaurs maybe having their wings broken by these strong winds. And then this is as the water is being churned up by the same storm. Maybe some of these scavengers and predators are being killed by this too. And so you get preservation of whole babies. They're not getting eaten by the scavengers. They're not getting eaten by the predators. And you get the whole babies just being deposited like that without being torn apart. Which might lead to a bias in which you get lots and lots of babies down there. That makes a lot of sense to me. Yeah. Cool stuff. Yeah. Yeah. Pretty neat. Pretty neat. Cool paper in Current Biology. Kudos to the authors. And it's lovely that it's open access too. So there you go. Again, if you'd like to read this paper, there's a link right there for you in the chat. Cool stuff. And with that, we've gone through all 5 of our bits of fossil news today. Ton of fossil news, exciting new discoveries. I'm jazzed about this. Really neat. Really neat. And with that, we will wrap up today's stream. Don't go away just yet. We're going to raid into Rhacodactylus, who's going to be doing some science discussion, I believe, on stream. We'll run our credits over this other Solnhofen critter, Archaeopteryx here, from the same place as those baby pterosaurs. Make sure Reiko is live right now. There we go. As is our custom, let's raid into Reiko like we do on Wednesdays. So from Pterodactylus to Reikadactylus. First off, thank you to everybody appearing in our credits right now, from new followers to raiders, to the subscribers and resubscribers, gifters and cheerers that make these streams possible through their financial support. I could not do this were it not for your generosity, your support. Thank you very, very much for that. From the bottom of my heart, I appreciate it deeply. Thank you to the moderators who help keep this a safe and welcoming community for everybody. Thank you for making it possible for me to stream by doing what you do, mods. I appreciate your dedication, your enthusiasm, and your viewership. To everybody who watched today, I know the internet is a big place. You could be just about anywhere, but you've been spending time here with me, talking about the incredible record of history of life on our planet, as told through the rocks and the fossils. It's such a privilege to be able to explore this science with you, and I'm grateful for your time. We'll be streaming again tomorrow. I will be late to stream tomorrow because I've got an important meeting about leatherback turtles in Monterey tomorrow. It takes a while to drive back from there, so... Anyway, let's go check out Reiko, see what he's up to, and I'll see you tomorrow, everybody.